voice okay, and also display. Voice and display, both are okay. Voice and display, both okay. Okay, we'll start now. Some 2-3 places you can see some light spot because daytime, and some windows are open because if it is closed, very difficult here because it is not that much hot but reasonably hot. Slowly that light will go because after 5:30, 5:45 it will become, that light will go. So not a big issue. See now, make a note. I'll give everything I want to complete today. Example 2 for combined footing. See, those who want, write the question. A combined footing is proposed for 2 columns 1 and 2. Column 1 is cross section 200 mm, popular 600 by, I'll take fraction value 200 mm by 625 mm, and column 2 is once again 200 mm by 575 mm. Okay, that's all in inches problem. Column 1 and 2, both in millimeter. It can't be meter, it can't be centimeter. Okay, now column 1 is supporting axial load of 1600 kilonewton. Column 2 is supporting axial load of 1400 kilonewton. Then in the question given, SBC of soil is, I noted SBC, 150 kN per meter square. For some reason, I want low SBC. See, last time 180, 200, this time 150. That's all. Little weak soil. And use M30 concrete and FE 500 steel. This is to be used. Or you will do one thing. Okay. Shall I make FE 415 for a change? Okay, I'll make for a change FE 415. Okay. For a change FE 415. Now, top is visible. Okay, little mark is there. Okay, I won't turn further. I can slightly turn, but I won't turn because if I turn, setting will go. So let it be no problem. FE 415. Now further, first you find area required by 1.1 total load by SBC for axial load only. Here, no moments are given. There are no moments given here. Just are not given. If it is there, what is there? You already know it. Our purpose is not that X bar, Y bar calculation or considering moment. Our purpose is how the footing slab will bend. Okay, now 1600, 1400 kilonewton are the 2 loads. Moments are not there. There's a reason for not giving moment. I'll tell you later. There's a reason for not giving moment also. Then further, area required over. Now, some area required will come. Considering if moments are there, you increase by around say 15-20%. But one thing, when you provide the footing, there is no guarantee that CG of the column loads or resultant line of action of column loads may not pass through CG of the footing. If it is not passing to CG, it will create moment M. Then again pressure will change. So even then it is better to increase by small margin, say some 15-20%. Somebody increased it. Then also in the question given, the see, these are all given. See now, I am dictating now. The 2 columns are spaced 6 meters apart. Little abnormal space. Reason is there. 6 feet spacing is there. There is no rule that 6 meters you can't give column. One here, maybe in between, they want free passage. Okay, 6 meters. Then the projection of the footing on either side are already fixed. Left side is 2.1, right is 1.7. And based on the area required, he decided width of footing, someone decided to be 2.5 meters. So this is the plan proposed. How to fix this distance, how to get this distance, how to get this distance, each and everything we considered in question 1. So therefore, no point in wasting time. If I start all that, this also will become that question. This week over, next week over, next week. No. I want to finish today not only this question, one more question, so that I want to conclude today combined footing. Next week in Zoom, I will go for other things like combined footing with the beams and raft. That's the last part, over. For that RCC also people will come. Then immediately software side. Okay. Now, but one thing, this is the proposed, but one note, somebody proposed and he gave the plan, this arrangement, and for some reason he is not continuing. Maybe he left the design office. Okay, now you are in charge of the design of this footing. So, and maybe, see, he has given 2.1 because maybe from this side another footing is coming. From that side a footing may come. Restriction of space is there. Or once it is 2.1, he does not want very high space. See, load is more, little more projection. Load is lesser, little lesser he fixed. 2.5 he fixed. But he told this much and that's all. This design is now transferred to you. Continue. So what you have to do? So you have to verify that pressure does not exceed maximum gross G. Now start. Now it is your duty. It is our duty, because he has not told anything about pressure. He told, okay, I checked everything and left. Somehow you don't have confidence. See, you cannot completely design the footing and later if you find that pressure exceeds SPC, then your time is wasted. So first what you do? Fixing the dimensions he has done. But why I have not done here? Time consuming. And therefore, to save the time, imagine I only fixed it. Okay, now our duty, if you tell I only fixed it, some will tell, sir, then no need of checking the pressure. Why? When you decide the footing size, surely you know how to control the pressure. Okay, I am an inexperienced person. Imagine that way. Okay. Our duty to ensure that what? 1. PG maximum does not exceed SBC of soil. SBC is how much I told? 150 kN per meter square. 1. Second one, PG minimum is not negative to prevent lifting. Here not negative, in software not positive. This I will tell in software. Over. You should not tell later. Those who are in the ETABS, sir, that day you told negative. That day I told negative because there it is compression positive. In software it is tension positive. So we want compression. Here you want compression, so should be positive. There you want compression, so should be negative. So positive means lifting. Over. Now start. First, consider the 2 column load. Put a line diagram. See, put a line diagram. 1 column load is here. How much? 1600 kilonewton. 1 more column load is here. I had not given moments deliberately so that SFD BMD all will come fast. It hardly matters. Everything we considered earlier. Okay, now that's all. This distance is 2.1 meter. This is 6 meter. This is 1.7 meter. I told this is A, this is B, this is C, this is D, lengthwise. And total length is how much? Total length is 6 meter. Okay, start. First, for the 2 column loads, resultant X bar from A, C equal to 1600 into 2.1 plus 1400 into 6 plus 2.1 is 8.1 divided by 1600 plus 1400. Tell the answer. Tell what is the X bar in meter. That will tell you where is line of action of resultant load. First, X bar. See, somewhere there you can't see it. I covered. I did so many calculations just 15 minutes earlier. That's why delayed. At 5 I suddenly remembered. Oh, I have not said the question. At 5 o'clock, I suddenly decided question is not set. So I delayed by 10 minutes and set the question here and noted down some important values so that what I want to get it. X bar, how much? X bar, fast. See, 4.9 meter. X come to 4.9 meter. Sorry, total length is not 6 meter. Why total length? 6 plus 2.1 plus 1.7. Tell total length, 9.8 meter. Total is 9.8 meter. Correct? X bar. 4.9. Okay. Now, therefore, you write here and then mark the footing line. This is C, this is D. This is the centroidal line from here to here. That is 9.8 by 2 equal to 4.9. This also 4.9. Oh, what is this? What is this? Your resultant column load exactly passes here. See, this is resultant of column loads because X bar you got how much? 4.9 meter. Therefore, line of action of resultant of 2 column load. You should write line of action of resultant of 2 column load exactly coincides with CG of the footing. Right here. Oh, what a surprise. What a surprise. Right? No surprise. I only set the question for X bar equal to half the span length. I calculated distances required so that line of action of resultant will coincide, because if the loading is trapezoidal, SFD BMD will take a lot of time. I very thoroughly explained SFD BMD. When loading is trapezoidal, there is no point in wasting my time in this class for those things all. We want diagram, that's all. Therefore, what happens now? Therefore, tell what? Upward pressure will be, what, tell me? Earlier I told upward pressure will be what? Will be. Upward pressure will be. What now? Line of action of resultant load passes exactly no M1, no M2. Upward pressure will be. What you can tell? This is set by me only. Even next example also I have set the same way. Not UDL. You should tell will be uniform. Will be uniform. Uniform. Or do one thing. Suppose you don't go for X bar. You go to other one. Tell what you will do. Or you can do one more thing. See. One more thing you can do. Mark center line of the footing. See. Center line here. This is 4.9 meter. This also 4.9 meter. Okay, now transfer 1600 here and also transfer 1400 here. So load transferred is 3000 kN, and this will create anti-clockwise moment of 1600 into, see, this is 4.9 minus 2.1. 4.9 minus 2.1 is 2.8. How much answer? 1600. This is second approach. What? By transfer theory. I did earlier also. Okay, try transfer theory. Answer has to tally. How much? 1600 into 2.8. What is the moment? 1600 into 2.8. Little fast give the answer. Don't waste time. 4480 anti-clockwise. 4480 anti-clockwise. That column load will produce clockwise moment of 1400 into, from 4.9 subtract 1.7. That will give you 1400 into 4.9 minus 1.7 is, how much it is? 3.2. Tell the answer. 1400 into 3.2. Answer. If answer is not telling, complete engineering mechanics gone. Damar. Engineering mechanics no more valid. That also is 4480. Oh, you write. Oh, even if you do by transfer theory, finally to CG of the footing, only column load passes. Therefore, in this case, you can tell for the complete footing. See, this is the CG of centroidal axis for footing. Exactly here, the load of resultant load, how much? 3000 kN is acting, and this is how much? 2.5 meter. The total length is 9.8 meter. That's all. You take corner A. I'll do one thing now. I won't take A, B, C, D. I'll take this as corner 1, corner 2, corner 3, corner 4. So, see, this moment M1 equal to 0. This moment M2 also equal to 0. So, you know, gross pressure anywhere equal to plus 1.1 P by A plus or minus M1 by Z1 plus or minus M2 by Z2. Both are damar, not there. So answer, anywhere plus 1.1 into 3000 divided by area is 9.8 into 2.5. Tell the gross pressure. Any corner, there is no maximum pressure, minimum pressure, no. Uniform pressure. Of course, I wrote what a surprise, not surprise. Such surprises I can create a lot. If you got rock footing, give me 50 columns, 100 columns. I will adjust the distances and I will apply some moment for the column, etc. I will see that complete raft consisting of 100 columns, resultant column load, I will see that it will coincide with CG of footing. Of course, half an hour required. 100 column is I will become mad. It is possible. Nothing. You have to think a little how one moment will come, how other moment will come, and balance it. Answer 134.693. 693 kilonewton per meter square. This is less than SBC of soil of 150 kN per meter square. Therefore, safe. Okay. Now, the second condition, PG minimum becoming negative, does not exist here. Why? First of all, pressure is uniform. Where lifting will come? So you write the second condition, PG minimum to be positive or should not be negative is automatically satisfied. Over. Now, therefore, footing size provided is okay. SBC is 150. For safety, he gave little more. Maybe 2.5 width is not required. I will tell you exact width required. So, how to calculate? What you put 150 here. 150 divided by 1.1 divided by 3000. I will take this side, then into 9.8. What is this one? No. You take that side. 1.1 into 3000 divided by 9.8 will give you 3 divided by 150. Actually, 2.244 meter or 2.25 meter. If you provide a width of 2.25 meter, maximum gross pressure will be almost equal to SBC. See, if you give 2.25 meter width, then 3000 into 1.1 by 9.8 by 2.25, 149.66 kN per meter square, safe. But the person decided, no, weak soil. Therefore, see, 150 is not a good soil. It's a weak soil. Since it's a weak soil, it is better not to overload it. So he decided to give it more width. Okay, agreed. So now, our footing dimensions are perfect. Start. Now go for structural design. All fast. No time waste to be done. Start now. Design principle, etc. Everything you should go through earlier classes. I cannot keep on repeating here now. First of all, this also I should not have told. I should have told you only work out and check the answer. Why should I give all this one? Those who are this all over now. See, everything over. Oh, I forgot now. Tell me now, answer. Now, for further step, you do not want gross pressure. Tell me what you require. See, for all further calculations or for all further steps, we need net pressure, that is Pn, net pressure Pn equal to only P by A. Answer. Total load is 3000 kN, real area is 9.8 by 2.5. Tell the answer. 3000 by 9.8 into 2.5. I want the exact answer. 3000 divided by 9.8 by 2.5 comes to 122.4489796. 122 point, I will write 449, I will write. Yes, I wrote down here. It is there. 122 point, I can take 449. Actually, it is not that way. See, it is 3000 by 2.5. If you write in other format, it is actually 6000 by 49. If you want exact value, if you use this value, perfect answer will come. But this point not something, who bothers? So it is 122.449 kilonewton per meter square. Over. Now start. First, you consider the entire footing. For first consider, I start from here now. Now see, steps will be over very fast. I want to know the space here. If I write here, visible? Yes, visible. Look this side. Okay. Somewhere here if I write, visible I think. Is it okay? Now, go for first lengthwise bending. No, I am not going to explain anything today. How many times I explained what is lengthwise bending, what is widthwise bending, what is punching shear, what is that one-way shear, etc., etc. There is a limit. And also, when we draw SFD BMD earlier, it was uniformly varying load represented by a trapezium. So there, to avoid trouble, we put one M-X and V-X. None of them required today. Why? UDL. But one thing important, if you remember, what? See, last time your pressure was this way. Here and here, what you do? You add these two, find average pressure, add these two, find average pressure, then average pressure multiply by 2.5, you get the load in kilonewton per meter. This time, no average pressure, nothing. So, now see, you light a beam here. See, consider entire width of how much? Entire width of 2.5 meter. I told you. Then you can see a beam action where, see, this I cannot remove away. 1 point load here, 1600 kilonewton. One more point load here, 1400 kilonewton. No moment. And this distance is 2.1 meter. This distance is 6 meter. This distance is 1.7 meter. No space there. 1.7 meter. I will call this point A, this point B, this point C, this point D, and there is upward UDL here. Anybody can tell me what is the upward UDL in kilonewton per meter? No meter square, because we want the lengthwise bending considering entire width. So when you go per meter length, anybody can tell what is the answer? I will not explain. Net pressure is 122.449. That is in kilonewton per meter square. That is kN per meter square. When you go by 1 meter length, full width to be considered. Anybody can tell what is the upward UDL per unit length? 306.1225. Yes, I wrote it down. Correct. It is 306.1225 kilonewton per meter. Suppose somebody will ask here, sir, not clear. Can you please explain that once again? I will tell no. I will not explain once again because it will be insulting those who are hardworking and what? Dedicated. They will tell, that much explained for averaging pressure, etc. There is no average. If you want to do one thing, 132.49, that one plus same thing divided by 2. It will come here. Once again, same thing divided by 2. Then you multiply. It is a fun actually. Okay, start. Now, SFD you can draw very easily. See, SFD and BMD, remember, everything is for 2.5. From here to here, go up. How much? 306. I will calculate. No. Now this time, that V dash X, M dash X, nothing required. V dash X, M dash X, nothing required. Directly calculate. I will draw the diagram. You try later. No time today. 306. But I will explain what I am doing. 0.1225 into 2.1 will give 6 linear variation today. No parabola. This is 642.85786 I will take. Come down by 1600. 642.86 minus, I am rounding off the decimal, 1600. 957.14. Again go up by 306.1225 into 6. That will be 879. See here, high value. Hey, you go that side. Don't come here. Go there. Okay, I will put here now. Here I can write. Troublemaker. 306.1225. Why you are disturbing me? When I want to write something there, don't disturb. 879. This is 950, little lesser. 879.6. 595 comes. Okay, 6, no problem. 6. It will go this way. Then come down by 1400. It is 520.4. 520.4. Go up by plus 306.1225 into 1.7. Correctly goes 0.000. Plus minus SFD kilonewton, just to understand sign convention. Over. Now, this point is required. Locate this point. This time no struggling. Why no struggling? Because similar triangles will do, or do whatever you want. You get the distance. I am not explaining one micromillimeter part of this one. If somebody does not like it, they can leave the class and not come to once again to my class. I should be harsh in such matters. But if wrong, tell me. It is 3.1267 meter. Okay, I'll round off. Or if I do from this side, I'll check the answer by some other way. It is it comes to 2.873 meter. 33 meter. Is it correct? 957.14 divided by 306.1225. 3.1267 meter. Correct. Now, if I add these two, 2.8733 plus 3.1267, I am getting back 6 meter. Correct. Over. Now, go for bending moment diagram. See now. Bending moment diagram. Sagging. No. BMD on tension side. Habit. What to do? Start. Bending moment here. 0. I am showing the calculation. Those who want should write with me. Not now. After the class, go through recording. BM at A. Look this side. Plus 306.1225 into 2.1 into 2.1 by 2 is plus came. Plus means sagging, tension down. It is somewhere here. 675.000 something. Leave it. 675. Bending moment here. Look that side. Once again plus 306.1225 into 1.7 into 1.7 by 2 is 442 positive, means sagging. 442.35 or 442.43. 3 sufficient. Who want? Now also bending moment here. Last class, see now that means what? This is sagging. Last time this came hogging, but when this is 6, this was 800 there, that came only 300. Means at that time overhangs are quite more, the spacing of column is little lesser. So what happened is, since overhangs are more, heavy bending of overhang, that span bending, if you can call, is lesser, but still it is hogging. But now also it will come hogging. But tell me, now, see, overhangs are 2.1 and 1.7. This is what? 6 into 0.1 minute here, 6 into 0.3, 1.8. Now here BM will be start 306.1225, 306.1225 into bracket open, 2.1 plus another 3.1267 into that distance by 2 minus 1600 into 3.1267. It comes to 821. Oh, minus. Negative comes. Negative means hogging. Oh, top tension. These all I explained last time. There's a limit for explaining. 821.3. See, last time what happened was sagging, cup. See, the drops all I'm not bothered now. It came this way. See, some 800 here, 600 here, 300 here. Because at that time, overhangs are more, span is lesser, sag, and smaller hog. Now, heavy hogging. So this question, the bending moment is very heavy, not at the sub columns here in the mid span. Last time, the sagging BM under the column was more than the hogging BM at or near center of the footing. Now not that way. Now hogging predominant. This last time, your bottom steel required was more, top steel requirement was lesser. Now not that way. Bottom steel requirement is lesser, top steel is more. After this one more question is there where I will see that top steel requirement is not there. Means what? Your BMD will come this way. For that to come, what happens? Column should be very, very closer. I will make it. So then I will give detailing for all. Okay, start brief detailing. Now here. Now join. Parabola of second degree, parabola. Okay, done. Somebody may comment. Let him comment. Okay, now there are 2 points here. I will take point O1 here, point O2 here. I will take, now you can take X from anywhere. Anywhere you can take X. Do one thing. See, you take a section between A and B at X from here. At X from here. If you want red color, you make a note. You need not locate O1, O2. See, you need not locate O1, O2 by 2 times like I did in SFDBMD course, because there in between point loads are there. Then same equation is not valid. This time between A and B there are 2 points where bending moment is 0, and between A and B these are standard point. No change of loading means if I write BM in terms of X equate to 0, it will give one X value for O1, other X value for O2. This time both are applicable. In the SFDBMD class I told something. You will get one applicable, one non-applicable. I told you that non-applicable value has some reason or concept. It is not nonsense value. That non-applicable value, what you used to get, is not a nonsense value. It has got a meaning. Remember it? I just slightly go back to that class. If you have gone through my SFDBMD class, that non-applicable value has got some sense, it got a concept, it got a meaning. Some people will tell that is non-applicable, nonsense value. What nonsense value? Everything in structural engineering you are getting sense value only. You don't get nonsense value. If there are two values you are getting, if one is non-applicable, that non-applicable value, how much it came, that much, it has got a reason or sense. People who tell it is nonsense value, they are telling nonsense things. If you believe me, you believe this also. Hope you believe me. You believe me? No. Are you believing me or no? If all these concepts slightly have gone beyond RCC now, why I could not resist that telling people telling nonsense values. See, I cannot resist it. I get upset actually. Values which has got meaning, people tell nonsense values. The statement itself is nonsense. Okay, now do one thing. Take at x from here. Then bending moment at x equal to, see here, it is minus 1600 into x. Not x. Into x. See, wherever you are between the 2 points, x minus 2.1 and plus 306.1225 into x by 2. It is the equation for BM for any point between A and B. Now, unknowingly to you, but knowingly to me, that secret I told now. That secret I told. But some will tell, no sir, this is not the way. The secret means you are not fully told. You are not fully told. Still it is haunting us. In the BSK class, remind me, I will explain only for my BSK batch. That concept, remind me in the BSK batch. Agreed? Those who are in the BSK batch, remind me when I finish bending stress part, the moment I go to deflection there, before that remind me. That nonsense value, non-applicable value, please explain. Please not required. You can order. I order you to explain. Yes, I will explain. Those who are in the BSK batch. Okay. And then equal to 0. By solving, can you tell x value first? See, it will give you two positive values of x. Both are positive. Answer. First and second answer. First, give. For accuracy, third decimal sufficient. Answer, x value. 3.1267. I want both the values. I want both the values. You calculate. Calculator will give you both the values. One is 3.1267. Oh, that is the old value. One of them will come less than 3.1267. Other will come more than 3.1267, but less than, no, not 3 point. It is from here. It is from here actually. You tell both the values. Both the values. 2.91 meter. Okay. 2.91. 2.9. Oh, you are rounding up to second decimal. I want third decimal. Okay, 2.91 and 7.543. Okay, and 7.543 meter. That means what? From here to from that means what? Bending moment equal to 0 at 2.91 meter from C and also at 7.54 meter from C. 3 is not required. From C. That is, tell the answer. Now tell me, see this x over now. I am removing the x now. But we want this distance. See, we want this distance. Tell this distance. Our 1x is 2.91. From 2.91, subtract 2.1. Answer. From 2.91, subtract 2.1, you will get the distance from here. How much? From 2.91, subtract 2.1. ಅದಕ್ಕೆ ಇಷ್ಟೊತ್ತು ಬೇಕಾ? This much time for that one. This much time to subtract 2.1 from 2.91. Okay, no, from 2.91 subtract 2.1. Why? 2.91 from here. Subtract 2.1. 0.81 meter. This is 0.81 meter. Remember, rounded means calculated. Other one, see, this is 2.1, this is 6. From C up to B is 6 plus 2, 8.1. From 8.1, subtract how much? 7.54. Answer. From 8.1, see, this is 8.1. Subtract 7.54, you will get this distance. You should make a note if you want. How much? Other one. From 8.1, subtract 7.54. 0.56 meter. Okay. 0.56 meter. All this clear? Or now do one thing. Okay. I will take a risk now. Unwanted risk. I want to locate this point once again by taking this as x. Tell me, my x has to come. How much? Tell me. My x has to come in my class. If I am handling the class, or if my class is to be continued further, x value has to come. How much? Tell me. How much? 0.557 meter. Then you round up to 0.56. As per that distance, it should come 0.557 meter, because it is actually, this is 0.557. Okay, I'll do one thing. I'll write 0.557 only. Okay, 0.557. Let me check it. Bending moment at x from here is minus 1400 into x plus how much? 306.1225 into x plus 1.7. X plus 1.7, that into x plus 1.7 by 2 equal to 0. Your x has to come. If it comes any value other than 0.557 meter, right now you tell me. I will close this class. You log out, close this class. I will delete my YouTube channel and stop taking any further structural classes. Answer. I will delete my YouTube channel. Why? I have no right to continue. I have no right to continue after telling so much high level things. I sometimes tell technical mistake I am not going to make. Answer. Answer fast. How much you got? If it is same, tell same. So people in my classroom, they will not calculate. They will tell, Istella helidmela mugis sir, same anta. But check it. Same. Thank you. Same. So that should give you confidence. See, any viewer, these things should give confidence. They should think that way. Oh, okay, no problem. This person at least knows something. See, at least knows something. If he knows at least something, let us learn that much. See, that way. ಕನ್ನಡದಲ್ಲಿ ಸ್ವಲ್ಪ ಆದರೂ ಗೊತ್ತು ಇವರಿಗೆ. इसको थोड़ा थोड़ा आता है. Not everything. Sometimes I have seen YouTube channels, पूरा ब्रह्मांड का ज्ञान यहाँ मिलेगा. I have seen it. No comment further. ब्रह्मांड का पूरा ज्ञान यहाँ मिलेगा. I have seen that ज्ञान. Okay, now to understand further, if you remember, see, this I remove now. Project this point O1. Project this point O2. This x is not required now. See, now, see, this is C, this is A, this is B, this is D, this is E, this is A, this is B, this is C, this is D. This I will call E. Here, A to O1, it is going to sag. O1 to O2, it is going to heavily hog. See, just to understand. Some will tell, sir, this elastic curve. No, exaggeration. Don't connect these two. Elastic curve will be smoothly like this. If somebody comments, I know that, I will tell, do you think I don't know anything about elastic curve? Deflection chapter, I have got complete control like any other subject. This is to exaggerate, hog. This will sag. This also will sag lesser. This will sag by maximum of how much? 675. This will hog by maximum of 821.3. This will sag here by 442.3. Now, see, the reinforcement required for this will be, see here. This is your A, this is your B, this is C, this is D, out of scale, sagging, bottom steel, theoretical requirement up to here. Bottom steel up to here, up to quarter flexion. Here, top steel. Later we will extend it. Now, this is the respective reinforcement required. Full clear? Tell fast. If this much clear, now you can non-stop go to remaining part and finish as early as possible. Okay. Now, start. First, now remember, now statement you have tried. You will not design the footing slab for the entire width because the strip which runs under the column will have severe bending, which has outside will have lesser bending. Now do one thing. Now consider 1 meter strip running under the column, under both columns. Okay. That is this way. One column here. So you take a strip here under the columns. Now, if I take a strip of 1 meter here, first of all, I don't explain here. I told the bending diagram. This diagram is valid, but because of the severity of the load under the column, more bending will come. So, what we will do is, bending moment values, we will increase by, how much, tell me? Say per side. In STAD Pro or ETABS not required. Why? ETABS you draw a strip here. That fluctuation ETAB will consider. You don't have to do, first of all, ETAB you don't have to do anything. Prepare the model, ensure pressure is in control, see the steel there, provide it, punching shear it will do, and then only check for one-way shear and lateral bending check, that also it will do, and prepare the drawing. This question, if you do in ETABS, it's a question of only 5 to 10 minutes for a person who got thorough knowledge, or 20 minutes for a person of average level. If you are below average level, better not go to structural design. Then you take 2 days also. Tell me, increase by, I told a percentage, around 25%. Therefore, for this trip, our BMD we will take, see, I will do one thing now. To save the time, I will do one thing. These are the factored BMs. Factored BMs for that 1 meter strip considered. You should do it. Tell the answer here. Factored BM. This is for 1 meter strip for that 1 meter strip considered. Tell the answer here. 675. First divide by how much? Sorry, I am not explaining. Go back to combined footing. Nearly more than 15 hours I took. 2 successive weeks, non-stop, class after class. Minute points are told. It is your duty to go back and start studying once again. Of course, that UVL part is gone now. Now that UVL is gone, tell the answer. First you divide by how much? 1 point. First I want for 1 meter strip. So whatever answer is there, first divide by how much? Tell me. First divide by how much? 2.5. First you divide by 2.5. Then not over. Increase by 25%. Okay. That will give working load. Then go for that important number without forgetting. So last time I wrote step by step. Here in one diagram, directly factored values. This is A, this is B, this is your O1, this is O2, C, D, out of scale. Tell the answer. Factored BM here. For 675, divide by 2.5, then multiply by 2, divide by 2.5, multiply by 1.25, also multiplied by 1.5. Don't give wrong values. Answer. Fast, fast. 3 values are required. Tell the value here. Don't waste time. Actually, I got the value there. I got 506.25. I think correct. Yes, I got 506.25. Remember, red color means factored and it is for 1 meter strip. Here, 442.3 divided by 2.5 into 1.25 into 1.5. I got there 331.8 or 506.3. Who will go for children? All kilometer meter. I got 331.8. Correct answer. And here I got this maximum sagging at E. I got 821.3. Is this also correct? Fast. Is this also correct? Fast, tell me. 821.3. Correct? Because I may make calculation mistake. So I do not want to give wrong values in the class. You check it. See, earlier to reach here, we took 2 weeks, not 2 weeks, 1 full Saturday, 1 full Sunday. Then also this was not over. 615.99. Adenge 821.3. Oh, no. Where is it? Oh, sorry. I am seeing wrong there. I saw the upper value there. It is correct. 615. 616, I think. Correct? I think 616. 821.3 into 1.5 into 1.25 divided by 2.5. Calculator is not on. Abba. See, the calculator is not on. 821.3 divided by 2.5 into 1.5 into 1.25. 616. I got 616 is correct. 616. I wrote 615 because I forgot to round up that number. 616. Right. This is the BMD on tension side. Start. Now, first, fix depth, capital D, based on BM, bending, based on BM. Equate MU to MU limit. See what depth will come for what bending strength. How to do it? MU which one? Maximum MU. That is, our last class it was here, now it is here. 616 into 10 to the power 6 equal to 0.36 into M15, M30 concrete, Fe415 steel. Remember, Fe415 steel. 0.48 into 1 minus 0.42 into 0.48 into breadth is 1000. Why? These are all the values for 1 meter strip into D square into FCK is 30. Tell fast what is the effective depth D required. Because see, I got a value there. Unfortunately, what happened is I took Fe500 there. Now, because I changed here, but if when you give the answer, I can make out. Slight change will come. And when you tell it, I will see my value. I will tell yes, correct. If you give nonsense value, I will tell nothing doing. Answer. Small d required. 615.9. The hale value. Oh, I came here to see what is the value. You are still in the old value only. I was so happy. Oh, somebody typed there. But that was the old 385.78. 385.78. How much I got? Yes, correct. It is 385.78 millimeter. But I got 854. No. I got doubt. I got slight doubt. 0.36 into x max by d into bracket 1 minus 0.42 into x max by d into 1000 into 30 equal to reciprocal into 616 10 to the power 6 equal to root answer. 3, oh correct, congratulations. I got, oh there is a capital D. Abba, I wrote capital D answer there. Okay. I added cover and root. Okay, leave it. I had not made a mistake. When I entered there, I added cover and root. Okay, correct. 387, right. Now, take 25 torr in the beginning. 25 torr at clear cover of 50 mm. Then, your capital D required will be based on bending equal to 385.78 plus 50 plus 25 by 2. Answer. 385.78 plus 50 plus 25 by 2. Answer. 400 and you should get slightly lesser than my value. Slightly lesser than my value. Little fast. 448.28. 448. I got 454. Correct. 448 point. How much? 448.28. Okay. Now remember, right here, this is the depth based on bending. But footing slabs are most critically shear. Accounting for shear last time, after increasing also we got unsafe there. We changed the steel. So based on shear, let us increase by around 75%. I stick to 75%. Practically, people take double. Tell the answer. If you increase by 75%, then D, after considering shear, D, how much? Increase by 75%. Answer. Increase it by 75%. Why? This much difficulty? To increase by 75%, this much difficulty. Oh, I never thought it is this. Increasing the value by 75%, I never thought it is so difficult. See, I told today is the last class. After this question, what all important I want to finish, I want to take next question, where I want width very high, so that so many practical cases it happens. It is just like two isolated footing joined together, but little saving of the length. Then lateral bending will become very severe. So I want that case, because why? This is practical knowledge. By chance, if a little portion left, no, today is Sunday. Next week, Saturday, I will give for YouTube class only. But I will try to finish today. For that reason, I will not do finish. I want to finish today. No, I will not do that way. Then why you take the class? Classes cannot be finished based on time. It has to be finished based on how much is considered. 784.49. 784.49, or say round off D to tell a number. Round off D. I also took same number. 784.49. 785. No, little liberal. 800. Round up to 800. Okay, now this all I will remove now. See, this everything will be removed. I am removing it now. And this diagram I want for some time. 1 minute. I want for some time, or I will do one thing. Okay. I want something so that, okay, this all I will remove. This sketch also I want it. Okay, now. Therefore, I will write here now. See, now this is not required now. Time being, leave it. Try capital D 800 millimeter. Therefore, with the 25 torr, in the beginning 25 torr, later we'll see what is the D actual provided. What is the actual D provided? That is 800 minus 50 minus 25 by 2. Anybody can tell? Actual D provided. Actual D provided. I get a small break for me now. I will tell you, well earned break. See, when you take a break, you should earn it. Someone should tell, yes, he told lot of things, he deserves a break. Not come, I've seen sometimes, take a class for 10 minutes, okay, we'll have a break. 737.5. You don't know, in the offline classes here, when I take class for around 3-4 hours or 5 hours, people are very happy for that word break. Oh, break. How, why? Sitting in front of me, here you can do whatever you want. Here everything is break only for you. Okay, now do one thing, check for punching shear. I am not explaining anything. Sorry, everything you perform. I will give the answer and go. You should tell me, tallying or not tallying. I will take 5-6 minutes break, but I will finish fast. See, nothing doing. Make a note here, critical section where, and then under both columns you require, I will write everything in a single sketch. I will put everything in a single sketch. One column here, one more column here. Column side you see there, critical section comes here. See, actually, ETAB or SAFE, even ETAB, you don't have to do it, that will do it. Now, start. I am starting. You can start yourself. So you can compete with me now. You can start competing with me. This is, if it is wrong, tell me, I'll check it. 1.3625 meter. 0.9375 here. This column load is 1600. You should know it. No moment, nothing. You know upward pressure. Everywhere pressure is constant here. 122.449. You don't have to do any pressure calculation. Other column, it is 1.3125. Other one is same, 0.9375. This is column number 1, this is column number 2. I will write here. For column number 1, I will put first V punching. V punching, therefore VUP punching. First you get punching force working load. First you get working load. I will write here now. See, I will write V punching for V punching, then VUP punching, factored, VUP. Then I will put tau UP. Then I will tell what is beta C, what is KS. Then what is, then I will put what is tau C. Tau C as per code. Then after tau C, I will put beta C. Then I will put what is KS. Then I will tell what is tau CP. Tau CP. Tau UP is the actual stress. Actual stress. This is the allowed stress. Allowed stress. Under column 1, under column 2. Start. You can start now. One, 4, 4, 3. This will be in kilonewton. 43.59 kilonewton. That column. One to 49.33 is the working load. 2165.5 4 kilonewton. One 187374 kilonewton. Kilo understood. Point 6382 there. Point 5647 there. Tau C 1.3693 1.3693 0.32 Ks equal to 0.82. Allowed is 1.1228 Newton per mm square. This is the allowed stress. This is the actual stress in Newton per mm square. There. This number is 1 point, that is correct. This is correct. 0.3478. Point 8478. Allowed stress is 1. Allowed stress is 1.1609. Therefore, safe here. Here also safe. And below I will write, I think, is it visible now? Is it visible? Okay. Now below I will upper side write. What number will come in ETAB? What number will come in software? In software, you don't have to do anything. I will write what number will come. In the software, at column 1, a number will come in a box. Same way it comes. There, if you right click, you see all these things. Who want to see all these things? You have no other work. So, software will give you 0.568 here. Oh, less than 1, safe. There. Software will give you what is that number? 1.3693 into 0.8478. It is 1.1609. See, number missed. See, I not look towards you. I simply use the calculator and closed. Software will give you 0.486, 4864. 4864, that's all, less than 1, safe. If when you go to ETAB class, nothing doing. I will tell you, tell the number. You can see in the model. Left column will show 0.568, sir, safe. Right column 0.48, safe, over. Some will tell, sir, over safe. No, one more shear is waiting there. Much more demon. This is medium hit. That is severe hit. So you should escape there also. So the 75% usually clears here and almost okay there. If unsafe there, we got adjustment. Slightly increase the steel. If you don't increase by 75%, this will fail. Instead of 0.568, you may get 1.5, 1.6 here, or sometime 2. Then you have to increase the depth. Okay, this is all over now. I will take little break. You should comment in the comment box that yes, all values are coming. After some time, I will not ask you. If you get the answer, okay. If you get the answer, okay. Otherwise, try later. I will take a small break. Let me see how many are getting both the answer. At least if anybody types got both, that means yes, you understood everything. Okay. Some 5-6 minutes break I will take. You start, continue and get the answer. Slowly see the light patch is gone now. Because why? It is becoming dark. Start. Don't waste time. Okay. I walked with the mic on. So what happened is the camera got pulled there, completely pulled. Okay. I have to once again set down. Oh, 1 minute now. The camera got fully pulled out because I walked with the mic. I forgot that mic is there. Okay, now tell me, is the display okay? Fast. 1 minute now. Get fast comment. Is the display okay? Is display okay? See, unknowingly I walked with the mic there. So that it rotated the camera here, full turn. Now I adjusted it. Tell me, is the full board visible? Is the display okay? See, that right side numbers are not required for you. See, those numbers are not required for you. Why? That is my personal number. Now, is the display okay? Please tell first. By mistake I went with my, okay, thank you. Everything is there. See, only camera got turned. Setting did not change. So, okay now. Next time I will be careful. I think I have. Sometime I will tell. When I tell I take a break, you give a comment. When the lag is not there, I will tell. In future, put one more comment. When I tell I am taking a break, you should comment. Be careful about mic. Till I use what? The mic without wires. Actually, mic without wire is available. But I am not going because it is quite expensive. This cost around, this is a Boya mic. Very good quality. That also is good quality. But this is around 700. That costs more than good quality 22. So therefore, goodbye to that mic. 22,000. That mic without wires. You request adapters all. I told no. Our level is not that much. That all for level. Okay, let the wire be there. You cannot see where. Okay. See, 5 minutes starts from now because I came back once again. think I'll turn the camera slightly. It is possible. Little turning of camera is okay. Because upper side is getting wasted. Okay, slightly I will turn. I can lift slightly. And one current here to push it that way. Okay, I think. Spirit level also is showing okay. Now display is okay. Now, is the display fully okay? Display fully okay? Everything visible now? I will start. See, as I told earlier, long class, in case some network problem or any problem is there, remember, by chance sometimes suddenly trouble comes. It is not here, it will come in, it Zoom also, recently it happened twice. Some network problem. Then, in that case, I already prepared 2 duplicate links. One under the name, today's class, I don't know, remember, extended. I prepared one more link called further extended. Both the links I prepared and kept it pending. It is not public. I made it unlisted. So in case some problem comes, I will end this meeting, then I will activate that link and make it public and send the link to you. If any more problem is there, I will cancel the later. If one more trouble comes, I will end that part, extended part, then I will go for further extended. Don't tell me you told further extended, it is extended further. Okay. That way I am planning for long classes. Short classes I make only one link. Long classes 2 links. If further problem is there, then it will take me to, after ending the class, I have to remove that unlisted and make it public. And I have to send link to the WhatsApp group and send. It may take around 10 minutes time maximum. But if all are exhausted, problem continues, every reserve is over. If 4th trouble comes, it may take 15 minutes then. I don't think that will happen. So remember, don't leave the class. Suddenly, those who are subscribed, they will get what? Notification. Or use why notification? You click my channel. That's all. When you click my channel, you can see live there. Live going on, you can see there. So then, live going on, you can see there. Therefore, you can continue. So in that case, be careful. Nothing to worry. This I always make one or two duplicate links there. Later, I delete it. When it is not required, when I prepare for next class, previous I delete. Okay, now start. See, now check for punching shear over, fully clear. I think D I will still maintain. See, now today's class, since you are repeating, I won't take any official break. Whenever some calculation comes, which you are able to do, that I will use for a break. So that class will keep on continuing. What is this one? 122.449. It is there. I don't know. That is not there. This all over. Hope everything you got now. Yes, I can remove. Further there, steel is not there. Why? Okay, now start. I will continue here now. Next step is calculation of longitudinal reinforcement for lengthwise bending. Equation for MU, you write, starting from 0.87 FY, etc. over. Then you know that B is 1000 millimeter. This I should not tell. Because why? These are the result for 1 meter strip. Estidu 331 point, see, rubbed out. 331.8. Okay. Rubbed out. Okay, now start one by one. First consider A to O1. 1 minute. Before that, do one thing. Before that, you calculate minimum steel. Minimum steel can be 0.12% of BD if it is a slab is considered, or 0.85 B into small d by Fy if you take the beam action. On this basis, minimum will come. You calculate later. 0.12% of BD. 0.12 divided by 100 into B is 1000, D is 800. 960 mm square. Whereas, if you consider 800 millimeter depth, this is not a slab, this is a beam. It is my private version, personal version. IS code people may tell, hey, it is slab. I will tell I am calling a beam. Don't talk. I will talk that way only. You call this a slab. Sorry for harsh words. Sometimes I get angry when people make wrong comment. 0.85 into 1000 into D is, where is D? 737.5 divided by 415. That comes to 1510. So we will take higher side. So remember, what we will do is minimum steel. I write here now. So therefore, we will provide minimum steel of how much? 1510.5. Okay, 1511 mm square. So if any steel comes less than 1511, provide 1511. If you get more than 1511, provide whatever you got. Start. A to O1. A to O1. Start. MU. 506.3 10 to the power 6 equal to 0.87 into 415 into AST. E red color, why red color? To show you that it is unknown. AST into D 737.5 into 1 minus Fy into AST divided by B is 1000, D is 737.5, FCK is 30. Solve the quadratic equation and take the least value. This all I told earlier. Take the least value, you get what is the AST required. I will tell you how the display will come in ETAB. Today I will tell you how ETAB display will come. Answer. AST required in mm square. Fast. Don't waste time. See, don't give wrong value. Tomorrow I don't want someone to comment and tell the values are wrong. He does not know how to calculate steel. My reply, then you come live and give the correct answer. If you don't come to live and give the answer, you accept whatever written. It is a misprint or miscalculation. You tell if something is wrong in principle, not this calculation part. That's why, but why give scope for such people? You don't know. There are so many people of that type trying to find mistake. They will try to find spelling mistake now. Consider. See. SI is not the, see, he wrote I, he forgot. He put COSE. Consider. Not in front of me. I actually write SI. Forgot to put the I. Why should I put that I? Is it an English class? One minute. Hello?
ನಾಳೆ ಕ್ಲಾಸ್ ಸರ್.
ನಾಳೆ ಬೆಳಿಗ್ಗೆ ಹೇಳಿದಲ್ಲ 9 ಗಂಟೆಗೆ ಅಂತ. 9:12. ನಾನು ಕ್ಲಾಸಲ್ಲಿ ಇದ್ದೀನಿ ನಾನೀಗ. ಇದು ಬೆಳಿಗ್ಗೆ ಒಂದು 9ರಿಂದ 8 ಗಂಟೆ ಕಾಲ್ ಮಾಡಬೇಕು ಮರಿಬಾರ್ದು ಮಾತ್ರ. ಒಂದು ಆದರೆ 7:45 ಮಾಡಿ ಸೇಪರ್ ಸೈಡ್ಗೋಸ್ಕರ. 9 ರೆಡಿ ಆಗಿರ್ತೀನಿ, 9:12 ತಗೋತೀನಿ. ಸರಿ, ಓಕೆ. ಈ ಕ್ಲಾಸಲ್ಲಿ ಇದ್ದೀನಿ ಈಗ. ಓಕೆ. See, you are not giving answer. One 1974.39. So actually what you do is you round up to next number. Because why? 0.3 mm square is what, first of all? 1975. Okay. Leave the decimals. 1975. 1975. Someone will comment here. It is 1974.3. 1974.39 is 1974 it comes. I will tell this is required steel. Round up to higher number, not your decimal number. Common sense, use it. Okay. That is comment from my side. Okay. This is more than minimum of 1511. Therefore, this will stand. This will stand. Tell the answer. 25 torr spacing. First answer. Spacing for 25 torr. Pi by 4 of 25 square divided by 1975 into 1000. First. Pi by 4 of 25 square divided by 1975 into 1000. Fast. Don't waste time. See, this is the time wasted. 248.54. 248.54. Okay, no, too high. 20 torr. 20 torr. Pi, all you have to do is that number divide by 25 square, multiply by 20 square. Over. That number, whatever you got, divide by 25 square, multiply by 20 square. Don't do once again formula. These are called shortcut. 1974. 159.06. Okay. 159.06 or 16 torr. There's a reason. There is a reason for it. I will tell you what. 16 torr, because I will tell you reason. 16 torr. 16 torr. 101.8. 101.8. Okay, now one thing now. You tell it. Please wait. Why please wait? Hey, wait. Wait there. Why should you request it? Okay, okay, please wait. Why? Because I will tell you something. Last time, if you remember, bottom tier, we provide separate diameter. That is theoretical. When I give detailing, we will make it same diameter. That's why this time, someone you should tell. This you are not told last time. I will tell it. Last time I went pure theoretical. This time, little practical. I will select later. 1 minute. Please wait. Okay, start. Now, this is bottom steel. See, this steel is bottom steel. Again, bottom steel here. See, remember, this is here. It is a bottom steel. This is a bottom steel. Again, go to don't go here. O2 to D. That is right side. O2 to D. This one. First this one over. I write here now. For here I got already I got it. How much? These numbers are there. See, 20 torr. No, I will put later. Or see, 25 torr you are not going. Okay, 25 torr means we got 248 spacing. 20 torr means we got 159. 16 torr means we got 101.8. Okay, wait for some time. Remember bottom steel. One more bottom here. O2 to D. Start. MU. 331.8 10 to the power 6 equal to, enjoy the calculation, tell fast AST required. Fast AST required. Same equation. Instead of 506.3, it is 331.8. And now don't go to interpolation. Why? It's a quadratic equation. See, someone told me long back. I will tell, not here. Retaining quality told me, sir, why don't you divide that by that bending moment, multiply by new bending moment? I told, open your eyes and see the equation for AST. Yes, sir. AST into AST is what? AST square. So variation is linear? No. Then quadratic you are going for interpolation or by proportioning. That is only for linear. Working stress method you can do it. There AST required equal to M by sigma ST into lever arm constant into D. There you can do it. Limit state you can't do it. If you remember in RCC class for those basic knowledge, I explained lot of these things there. About M by sigma ST JD, I told the reasoning there also. So many things are told, if at all you remember. AST. 1277. 1277. 1277 is again more than minimum. So 1277 will stand. Oh, no. It is less than minimum. How much minimum? 1511. Therefore, provide AST, how much? 1511. Start. 25 torr, don't waste time. Tell the answer. 20 torr spacing. Why? There only for higher requirement, we cancel 25 torr. Now BM steel is lesser. Why you want to go diameter? 20 torr spacing. 20 torr spacing. Pi by 4 of 20 square divided by 1277 into 1000. 207. Okay, 207. And 16 torr spacing. Divide by 20 square into 16 square. That's all. Little fast. 133.06. Okay, now stop. Therefore, do one thing now. See, this is here. I write here. Bottom, see, this is a bottom steel. This is bottom steel. This also is bottom steel. Bottom steel. Top steel is here. Here. 20 torr spacing came 207. 16 torr spacing came 133.06. Okay, leave it. Lastly, I will decide. Okay, now, lastly, between O1, O2. Between O1, O2. See, earlier two were sagging BM. O1, O2 is hogging BM. BM is 616. Answer. AST required. First. AST required. 616 is the bending moment. AST required. I will tell you later what ETABS will tell you. I will tell you display later. What ETABS will tell you, I will tell within no time now. See. Two four. One nimisha. Required steel is 1974 here. Required steel there is 1511. 1511. This requirement, how much you told? 207 point. This requirement you told 2424. 2424 mm square. Once again you are right now. 2424. 24. More than minimum. So tell the answer. Therefore, 25 torr spacing. How much? 25 torr spacing. 2424 25. Pi by 4 of 25 square by 2424 into 1000. Irli 25 torr. 25 torr spacing. 202.5. 202.5. 20 torr spacing. 20 torr spacing. 20 torr spacing. 20 torr spacing. I will give more information for detailing later. Don't worry. In the YouTube only I will give detailing for you. Briefly. Furthermore, I will tell in, or I may not tell here. I may tell it in the Zoom class only. Why? Everything I cannot tell here. Depends upon time slot. 129.6. 20 torr is 129.6. That's all. Leave it now. So here I got for this steel, top steel, how much? Top steel I got 25 torr at 202. 20 torr I got 129.6. Okay, leave it now. Now I will tell you what ETAB will give you. ETAB will give you a line. If it is a beam, see, if it is a beam I will tell you ETAB, but SAFE will not give it. I don't know why. SAFE you have to move the cursor. See, in the SAFE, when you move the cursor here, it will show you steel required 1974. When you move the cursor here, it will 1974 will come at the bottom. It will come, number will appear at the bottom. Means what? Bottom steel. When you move the cursor here, ETAB SAFE will tell you 2424, number will be on the upper side, top steel. When you move cursor here, it will tell not 1511, it will tell the requirement is not 1511, it is 1277. That adjustment you made, minimum steel, it will show you 1277. Okay, now, if it is ETAB, what will happen is, a line will come where it will divide here, see, it will give bottom number of 1974, bottom number here, it will give bottom number 1974, bottom number 1277, top number here of 2424. That's how it will come. Here 0, 0 and 0. 0 means no compression steel. This is what ETAB will give you. If a number appears here in the beams, it becomes a WA in post section. This all I will tell in the ETAB class. In the ETAB, we will start modeling right from simple beams only. See, when you do project, before you do the project and go for detailing, you should know elementary details. Without knowing elementary, if you go there, your building will have thousands of numbers will be there. You should know correctly when you click a member what each steel represents there. Okay, now this is over. Now what we will do is finalize. See, finalize steel. This strip I will remove now. It is no longer required. I will write here. Therefore, the final steel you are going to give is, see, you can still maintain the bending moment diagram. You can make one more note. Draw the diagram. Bottom steel, and top steel. Column is here, column is here. This is the theoretical way. Later, this is your O1, this is O2, this is A, this is B, C, D. This is the theoretical. Later, you have to extend here, this you have to extend, and you have to consider development length all. Here, number coming, see. I want to give same diameter here and same diameter here. Why, tell me? So that reinforcement can be easily placed. So what I will go for here is, see, 16 tor 101, there 16 tor 135. I will make it 16 tor at 100. This I will make 16 tor at 133 is there, 125 liberal. This I will make 20 tor at 129, 125. This is the proposed steel at present. Later I will tell you how to arrange all the steel. I may not tell in the YouTube class. If not in the YouTube Zoom class, I will tell. That is for the applicable batch. But depends on the time. I cannot continue long time, much more, because so many are waiting for software. Some will be telling already, he is not coming to software. Maybe he is not knowing software. Everybody thinks that way. Software will play the way I want it. Remember, I may be slow in control buttons. I am not slow in software control. The way I want it, it will behave that way only. Okay. This is the steel. Clear now? Because for shear you require. Clear? Clear or not? First, at present tentative reinforcement detailing. Over. Start. Now, this bending moment diagram I am removing now. I don't want to waste space. Start now. See, miracle. 5 o'clock started, 5:10 started, little small break in between. It is 7. Problem is almost getting over, whereas to reach here, you took more than 10 hours there. First question. Now, check for shear. Check for one-way shear. Next question, what I am doing is, I will put the question here in front of you. I will keep on solving and write the answer. Anything. I will not even ask you clear or not. Except one point I will tell. CBMD came this way. So, bottom steel here, top steel is not required. That the one and counterflexures are not there. Except that one, I will not tell anything. I will keep on writing here. Somebody will tell YouTube class. He is taking class in YouTube. He is not explaining anything. He keeps on writing on the board. Then he told, okay, solve it now. Is it the way to teach? I will tell him, go to earlier class. That is the way to teach. When you do repetition, second time explain little more. Third time same thing means don't tell even little also. Okay, start. First, critical section. This is one-way shear for lengthwise bending. Okay, critical section at D from face of column. Remember now, today we will use Excel. I don't know. The person with Excel, is your Excel ready? Today we will use Excel now. Because why? Last time systematically done. Tell me, the one who got Excel, is he ready? I think he is not there. Today he is absent, I think. Oh, problem. See, Nanda Kumar, are you there? In the comment section, I am not seeing your name. Usually when you come, you always give the comments. Since your name is not there, there is no Excel for us today. If he is there, he was there. No, he didn't. Today he is absent. Yes, you are there. Excel ready? Okay. Your Excel is ready? No. Excel ready means tell fast. If Excel is ready, we will use Excel. Those who want systematically can do manual later. No, Excel ready means tell me. Is that Excel sheet ready for checking for one-way shear? Yes. Ready? Okay, start. Now. First, remember, now I will tell it in such a way that it is useful for YouTube class. Sorry, what YouTube class? ETABS&SAFE class. See. Now you need correctly column side. This column side is point. Okay, I'll put a little bigger. See, this I already explained last time. So nothing more to explain today. Okay, done. This column side is 0.575. This column side is 0.5. This is 0.625. Okay. For lengthwise bending. I told how many times? Lengthwise bending. This is 0.625. This is 0.575. Then one critical section will come here. One critical section will come here. For this one critical here, one critical here. Under this column, this is distance D, this also distance D. This is distance D, this is distance D. You know your D in meter is 0.7375. 0.7375 meter. Therefore, tell me what is this distance. First, see, from 2.1 meter, 2.1 is up to center. Subtract half of 0.625. Also subtract D equal to 0.7375. First this number. Tell the answer. First this number. That number in meter. From 2, how much it is? From 2.1 subtract 0.625 by 2, also subtract 0.7375. Don't give wrong value. 1.05. Don't give wrong value. 1.05 here. Okay, now second one, I want from here only. I want from here only second one. Tell the answer. 2.1, you add 2.1 is up to center. First of all, sorry, why should I tell this one? It is told so thoroughly earlier. Again, see, this is my nature. I forgot that millimeter I told earlier. 2 means not numerical 2. 2 other K. Usko. For 2.1, add half of 0.625 and also add 0.7375. Tell from here. Tell from here. First, 3.15 meter. Now, tell me here. to this I want this distance. How? From 1.7 subtract half of 0.575 and also subtract 0.7375, this distance. Also subtract 0.7375. Any chance today? Shall it come tomorrow? 0.675. Don't give wrong values. 0.675. And I want, if that is 0.675, I do not want that distance. If you are going to SAFE and ETAB, we require this distance, correct? Nodi, innondu we need this distance. Why? In the SAFE, you have to move the cursor with respect to distance from here. Tell me. From 9.8 subtract 0.675. So I am matching with what? ETAB class. Because this class is meant for ETAB only. For others, theoretically I told last time. If you are learning ETAB, good. Otherwise you try. Earlier, when it is a uniformly varying load, I told millimeter things. 9.125 meter. And then tell me what is this distance from here to here. This distance. Tell the answer. To 1.7 add half of 0.575, also add 0.7375. This distance. To 1.7 add half of 0.575, also add D equal to 0.7375. ಎಷ್ಟು ಬೇಕಾ 2.725. Don't give wrong values. 2.725. If that is 2.725, from here to here will be from 9.8 subtract 2.725 here. From 9.8 subtract 2.725. 7.075. Now I will tell you. Now use the diagram here. This point is somewhere here. This point is somewhere here. This point is somewhere here. That point is somewhere here. You tell me what is the ordinate here, what is the ordinate here, what is the ordinate here. You can do similar triangle also. What is the ordinate here? Or calculate. Here you calculate. Oh, I will give these values, ordinate values. Because I can find easily. Don't worry. I know little of SFD BMD. Not that much bad. Not that much bad. Oh, calculate not on. 306.1225. Store A. Okay. Shift store A into distance 1.05. In the shear force diagram, if you calculate, this will come 321.4. Those who are interested, come here, look this side, find shear force. Then come here, look this side, find shear force, account for UDL and point load. You can do whatever you want. Into 3.15. This value will come 635.7. 635.7. Come this here, find shear force here. Look this side. It is into 7.075. 565.8 is this value. 565.8 is this value. And here this value is 293.4. This is 293.4. These are not the, remember, these values are not our shear force values. We want factored shear. We want factored shear force. I will do one thing now. I will put a dot here and write what is VU here. 1 minute now. I will do one thing. I will project here once again. See. Okay. What I can do. Okay. Now, what I can do is I can rub this chuck name. Chuck name is not required. This is not required. I will tell you now. Here and here and here and here. 4 points. I want what? I want VU for 1 meter strip in kilonewton I want at these 4 points. Remember, these are all the values you get for a width of how much? 2.5 meter. To get the shear force per meter width, you divide by 2.5. That will give you working load shear force. Then multiply with the factor of 1.5. You get VU for this one. Or last time I told, how many times I will explain? You will get 2.5, you divide 1.5 by 2.5 is 0.6. 25% is not required because, why? I told you, for shear, 25% not required because under the column, widthwise bending also is there. Therefore, lengthwise bending effect become lesser. So that will take care for shear. Bending here, I told 25%. Shear not required, 0.6. Tell the first number. If it is 321.4, tell the first number here. At least tell me one number. Tell the first number. First number. 206.63. Why? Why 206.3? 306.1225 into 9.125 minus 3000. I subtracted some other number. Okay, sorry. 206.6. Print mistake. See, good thing. Thank you. That I subtracted. See, last time column load total was 2500. My next question also I set for 2500. This time it is 3000. I forgot that 3000. You check one thing. I forgot that 3000. I used the old value. Okay, that is called print mistake, not technical mistake. I can check from that side. Tell the answer then. If I check from that side, answer is 306.1225 into this distance is point. I forgot. This number I don't know what is that number. How to get that number? Some number you told. 0.675. 205 point something. Correct. See, 205.1. I don't know. Some decimal error is there. Okay. So you can always check it. But I have not checked. Okay. Print mistake. I don't have to tell sorry for it. So it is 206 point. How much it is? 206 point how much? It is 206.6. Okay. Now tell me the shear force number here for 1 meter strip and factored value. Divide by 2.5 but factor it by 1.5. First number at least 192. I think 192. 321.4 192. You have to divide by 2.5 and then multiply by 1.5. 0.6 into 321.4. 192. Okay. It is correct. I made a mistake. 192.668 8 kilonewton. Here. And here shear force is 635.7 into 0.6. 381.4. Children badabidi. Or I'll put 193. Who bothers about decimals? 382. See, don't bother for children. Children means round up to higher side. Tips. And here 565.8. 565.8 into 0.6. 340 kilonewton. There 124. Okay. Now make a note. See, make a note. These are all the shear posts. This is to be used in place of VU. VU, that is factored shear force for what? 1 meter strip under the column. Over. Now make a note. If you are using ETAB, no calculation, nothing. You move the cursor to this point, it will show you 193. Move the cursor here, it will show you. You type, you go for 3.15 meter. 3.15 is not possible. Slight adjustment of hand, it will give you 382. Move the cursor here, 340. Move the cursor here, it will give 124. No calculation of strip, because ETAB will calculate per meter strip only, provided you draw a strip of 1 meter. Then it will always give you factored value. Remember, not this way. It will consider all the load combination. If it is a big building you are doing, dead load, live load, dead load into 1.5, live load into 1.5, then dead load into 1.2 plus live load into 1.2 plus earthquake this way 1.2, this way 1.2, that way 1.2, this way 1.2, then dead load into 1.5, earthquake into 1.5, some more than 30-40 combinations. It will, everything it will consider, it will give the critical values here. But if you go for practice problems, see in ETABS&SAFE, in the building, what comes, we will not be knowing. Why? It considers all the combination, it gives you critical values. But when before going to building project, see, I announced around 80 hours time. Today I am sending a brochure for those who are joining new, not for you, for today or tomorrow. There I wrote 80 hours. In the 80 hours, around 45 hours I need for basic tools. How to assign load, how to read member property, how to see the result, how to design a beam, how to design a slab, how to design a column and footing. There I will try to make the same model. That all I require. Then you require building project. Building project, around 10 hours time, I will not be taking. Some expert is there who will tell you about that layout, where to give beam. See, if I go here, that beam is not visible, problem comes. Staircase when you go, beam should have problem. That is functional requirement he will take. Then I will once again take over. Once the model is made, result again I am only coming. I will not ask him to continue. He is really good in that also. But that I will take over. These all I will take over. But that preparation of the importing, exporting, that he will do. He will show very neatly. So many people earlier, they told, sir, extraordinarily good. So told, okay, I will learn. They told, sir, in that, sir, not structures. He is so popular. Beautifully he will explain. And that portion, it is not my field, architectural part. Sometimes what will happen is, if I give a beam, my friend used to tell, hey, if you give a beam there, it will hit your head. Oh, I didn't see it. Why? Who will imagine all those things? So that layout he will prepare. But again, structural part, I will take over once again. So I need another, at least what? Little more, around 20 hours I require there. So around 45 hours I need for what? All the making you perfect in ETABS&SAFE. So that everything you should know. ETABS&SAFE, what this number means, what that number means, everything. See, how to read this values all. Building project I can't explain this way. How many columns are there? Okay, now start. Now I will use the space somewhere here. One check I will do, one check you do. Now remember now, consider column, see, consider here. Consider near A. Near A. Tell me, what is the VU critical? Critical VU. First, look this side, look that side. 193 and 382. Fast. Critical VU. How much? Critical VU. Directly you will get in the YouTube, sorry, not YouTube. Too much of YouTube classes. Directly you will get in ETABS&SAFE, not YouTube. YouTube, nothing. 382 kilonewton. VU 382 kilonewton. Okay, now 1 minute. And there, what is the AST provided? What is the AST provided? Tell the answer. 16 torr at 100. At 100. And depth of the slab is 800. Clear cover is 50. Then further, 800 depth, clear cover 50. M30 concrete, FCK 30. That's all. Tell me, use the Excel sheet. Tell me tau V value and tau C value. Fast. Nandakumar will tell tau V value. Nandakumar will tell tau V value. Type VU 382. 16 torr, you type spacing 100. D type 800. Clear cover default 50 is there, I think. And then M30, FCK 30. That's all. Steel is not required. Answer. Fast. Nandakumar, your Excel sheet. Excel sheet. Fast. What happened to your Excel? Tell me, it is safe or unsafe? Tell me that one. But tell me, safe or unsafe? If you have hidden everything, time being, open it. Then again close it. 0.526 is tau V. Tau V is danger number. 0.526 Newton per mm square. Tell what is tau C. Tau C how much? Tau C. Those who want write tau V equal to VU by BD. To get tau C you require PT. PT equal to 100 AST by BD. Calculate. Go to IS code. Open IS code. Table number, some table number. How much for 0.15, how much for 0.25, how much for 0.5, etc. Interpolate. Finally compare tau V, tau C and struggle. 0.428. It is 0.428. Therefore, Newton per mm square. Sorry, this is not red color. This is the black color. Why? It is a wanted number. This is your money in the pocket. Money in pocket. Someone will laugh. This is your bill. Oh, bill is coming 526 rupees. Only 428. Therefore, your tau V, this value is more than danger. More than tau C. That is, no, tau C is black. Tau C, that is net number. Not safe. Okay. Not very, or you can increase that. We will do one thing. Change the steel. Change steel. Okay. Do one thing. You are given 16 torr 100. Make a note. 16 torr 100 you are given. You cannot reduce the spacing below 100. People do not want a spacing less than 100. So what you do? Change it to once again 20 torr. You try 20 torr at 1 minute. Tell the answer. 100. You should make a note, those who are interested. 100 divided by 16 square into 20 square will give corresponding spacing for 20 torr. See, 16 torr at 100 is equivalent to 20 torr at spacing. Is equivalent to 20 torr at. Bega, high spacing will come. 100 into 20 square by 16 square. You are taking lot of time. If you do this way, next week also I require 156.25. So, if you give 20 torr at 156.25, it becomes same steel. So, do one thing. I want to put more steel required. So, go for 20 torr at 125. Let us see. Do one thing. Therefore, in the Excel sheet, type diameter 20 and spacing 125. Tell me what happens now. Tell me, now your tau C becomes, answer. Nandakumar will tell what is tau C equal to. Those who want to manually calculate new PT, go to IS code and get it. Now your tau C. Is it still unsafe or safe? From 60, to replace 16 torr at 100, 20 torr requirement is 156. Say 150. But no, we want to give more steel. So try 20 torr at 125. Safe or unsafe? Unsafe, Tell Tausi. Tausi value. Oh, from 0.428 it gone to 0.479. Oh, Tausi is still 0.479. Oh, tau is 0.526. Or try 20 torr at 100. Now tell the answer. What about now? Tausi. It is 0.479. 0.479. Unsafe. Change the spacing to 100. Give more steel. Change the spacing to 100. Now, what will happen? Tell me, Tausi, unsafe or safe? This is not safe. See, still not safe. Still not safe. Change it to 100. Change it to 20 or 100. Then, tell the answer. What happens now? In the Excel sheet, 0.535 is Tausi. Tausi is 0.535. What is Tausi? Oh, safe or unsafe? Tell me. Safe or unsafe? Safe or unsafe? It is safe. Or do one thing. Try something else. 20 torr. Oh, 100 is safe. Instead of 100, make 110 center to center. Slightly reduce the steel. Now tell me. Make it 110 center to center. I will tell you why 110. Why 110? I will tell you later. Why it is 110? I will tell you later. Tell me. Make it 110. See, you can play in the Excel. Safe or unsafe? If 110. 0.51, unsafe. Oh, it is unsafe. 0.51, not safe. Okay. 110. 105, I will not make it. Or leave it now. Therefore, finally right here. Finally, come back here. To make safe in shear, 16, 1 minute now. So you are changing to 16 torr at how much? Tell me. No, not 16 torr. To make, I will cancel this one. I will revise it to 20 torr. Tell the answer. At what spacing? Detailing, I will change once again this one. But I will give more steel, not lesser steel. 20 torr at how much? So you got a safe one. 20 torr at how much? 20 torr at 100 you will make it. Okay, 100. Subject to change if required. Over. Now, consider column B. Consider column B. And near column B. Then the maximum shear force factor is 340 kilonewton. See, it is 340 kilonewton. Correct? Start. AST provided in the beginning is 16 torr 125. At 125. Center to center. Tell the answer. Tau V, how much? Tell me. Nanda Kumar will tell now. You type shear force 340 kilonewton and once again go back to 16 torr 125 and tell me what is tau V and what is tau C. Or tell me safe or unsafe. I know it is not safe. See, even after increasing by 75%, see, shear is hitting you. That means you know shear is very critical in footing. Yes or no? Even after punching you escaped. That is a medium hitter. This person is solid punch. Answer. Change the shear force to 340 AST original value 16 torr at 125. 125. Tell me safe or unsafe. Fast. Nandakumar, what happened? Excel. Excel sheet prepared by us in the class. Those who want can go to rigorous calculation. You should tell little fast. Go to Excel, type shear force of 340, change the diameter to 16, spacing to 125. That was, still you are not telling answer. Unsafe, Okay, unsafe. Tell what is tau V value. Actually unsafe, that is sufficient for us. Still, for curiosity, what is tau E value? What is tau E value? Let me know at least. Why it is unsafe? How much is the margin? Or a number will come there, unsafe number. It will come more than 1. Tau E is 0, no? Here 0. Tau E is 0.468. What is tau C equal to? Actually, you are taking time equal to manual calculation. I can as well do manually. By this time, I can do manually also. Tau C tau C tau E 0.468. Tau C, you tell those values. Number you decide later. That we are using in software, not now. That all you use in software, not here. That Excel sheet further 0.383. Okay, 0.383. Therefore not safe. Now do one thing. Change to 60. Here you are given 20 torr. So better give here also 20 torr. Change 20 torr at here how much spacing? 100 spacing. You try 20 torr. See, tell the answer. 16 torr 125 is 16 torr at 125 is equivalent to 20 torr at what spacing? Tell the answer. 125 into 20 square by 16 square. If I ask you, you will take 1 year to get it. 125 into 20 square divided by 16 square is 195 spacing. You are not giving any answer. See, I don't know what happened today. Is equivalent to 195. But we want to give more steel. Try 20 torr at 150. Now tell the answer. If I go 20 150, tau E remains same. Tell what is tau C now? Tau C will increase. Tell me, when you type 20 torr at 150, tell the tau C value. In Excel, tau C. Now you are giving the answer 195. After I finish everything, if I change the steel to 20 torr at how much? 20 torr at 150, tell what is tau C value. Too much of time. You are wasting a lot of time here. This delay is creating problem. To type, give each value, if you take this much time, I can as well manually calculate then. I am not so weak. See, 0.438. 0.438. Still not safe. Okay. Now do one thing. Go to 20 torr at 125. Now tell the answer. 20 torr 125 make it. Finally what I will do is this and that both will make 20 torr 100. And in between continue alternate bars. See, we will provide 20 torr 100. There also, after traveling for distance of requirement development length or some requirement contact pressure point, central portion not required, we will provide alternate bars 20 torr at 200. That's what you are doing. That's what everybody is doing. Someone will tell, what is this? I say, provide. Somebody will tell, full span, provide 25 torr 100. There are people who will design everything. Last moment he will tell, hey, full put 25 torr 100. Sir, that is 60% more steel, sir. Provide. Are you paying? No. Somebody black money is paying. Don't worry. He will tell. Somebody building ground plus 20, ground plus 30. One thing is sure. 99% case, it is not legal money. It is earned by shortcut methods. Not 100%. There are people who work hard and earn money, not that way. Usually people know, hey, black money. Provide. Tomorrow no one should question us. We should be safe. 0.479, 0.479. If it is 0.479 black color, it is safe. Why? Point. Therefore safe. So finally we are going for here also 20 torr at 100 center to center. Over. Therefore now our steel is changed. See, Our new steel arrangement is, what, tell me? 20 torr 100. This also 20 torr 100. Top steel here is 20 torr 125. See, that will tell you, hey, what is this? Why? My bending moment is 800 as per this diagram. Your bending moment is lesser. For your lesser bending moment, you are giving more steel. I have got higher bending moment. But you tell for bending moment, their requirement is lesser. It is because of shear. So what is your problem? I am more. Okay. Okay. You are also 100. Okay. It will tell okay. Okay. Thank you. It will tell okay. You are also 100. Someone will tell this are 20 torr. You are also 25 torr. See, but that bar will be taken beyond the column here, then you will take alternate bars. So detailing, I will tell later, not right now. But at that time, remember, you should tell me these values. See there, I will ask you later, tell the bottom steel finalized, tell the bottom steel finalized, tell the top steel finalized. You should tell 125. Then I will tell, provide 100 there also. You should not make a note. You should not take half an hour then. Yesterday's class problem, I think I forgot now. See, when you do shear, we finalized it. You should repeat fast at that time. Don't waste time at that time. Okay, now everything is finalized. Now go for what? Tell me. Anybody can tell? Now go for. Tell me. What go for? Fast. Now go for. Now go for. Fast what? Over. Everything over. Now go for. Closing part of this one. Istone difficulty. Now go for. Fast, fast. I am not taking break now because I want to start next question and bring it to a stage where I will tell you, you continue. This much delay is too bad. Now go for. Don't tell go for a break or go for coffee. Now go for. Why nobody is responding? Someone will comment and he is seeing recording. He will tell to neighbors, see this person looks, what he tells, students are not following. When he is asking a question, nobody is answering. So it is no use using this class. Let us go to some other class. See, that class is better. He will finish a footing design in only half an hour. This person, I am seeing non-stop. Class number 16, 17, 18, combined footing, as if there is no end. See that person, see, half an hour, he will finish combined footing. So good. That is what called what? Real talent. This person is no talent. See, you are still not answering. Go for what? I may wait for some time and close the class if you don't answer. But I want to see whether I can hear or not. Checking is very easier. That class is better. See, yes, I can hear. Because if I increase the volume here, if I unmute here, I can hear my voices. See? 17, 18, combined footing. Now go for IPL finance. IPL finance. Why bother about it? We are not there. First of all, we means whom? I never consider RCB as our team. I never consider RCB as our team. Long back it was maintained by Kumble and who was there? Padikal was there, KL Rahul was there. So many people were there. At least what? At least some respect was there for our team. But now it is completely outside team. Only name is Bangalore. And one person who was very arrogant, he paid a very beautiful price. I'm happy, really happy. For the penalty, you should know, if you insult people who are really good and gem-of-hearted because of your talent or fame, one day you are going to pay the price for it. Yes, he is paying severely now. Now He is nowhere near anywhere. He is no person now. Okay, just 1 minute. Now go for 1 minute. Widthwise bending. No, not right now. Let me finish this one. Now, let me finish this one. Okay, 1 minute now. Now go for, now it is, still time is there. Widthwise bending. See. 1 minute now. See. I will not explain too much now. Last, add one more advantage. See. One column here. One column here. Take a strip here. 1 meter strip. Take a 1 meter strip here. Everything refer last time class. 1 meter here, 1 meter here. And fortunately today, this projection and this projection and this projection and this projection all are equal. Tell the answer. 2.5 minus 0.2 divided by 2. Answer. Today all the 4 are equal, so you are happy. And loading also same. This will be over within no time now. Within no time this will be over. 2.5 minus 0.2 divided by 2 will give all round projections. This is the strip, this is a strip. That also you are not telling. 1 meter. 2.5 minus 0.2 is 2.3. Divided by 2 is 1 meter. Yava calculator adu? 1.15 meter. How you get crazy ideas? 1.15 meter. 1.15 meter. 1.15 meter. Now, whether you cut here and see this side, or you cut here and see from this side, whatever you do, you are seeing only one sketch. See, I am removing everything now. Can I remove? Yes, I can remove everything now. Yes, you are seeing only one sketch. Why? Only single sketch will do. And this way. See. Now, it has got UDL this time. Remember now, since you take 1 meter strip, we want intensity in kilonewton per meter square. That is nothing but, I rubbed it. That intensity is 306.1225 kilonewton meter square. Now, this is a cantilever. This is the cantilever. This will, this UDL is 306.1225 kilonewton per meter square. And now, this is a cantilever. This is a cantilever. It is this cantilever or this cantilever. This is this cantilever or this cantilever. This will bend like this. This will bend like this. So you require bottom steel this way. Therefore, and both are equal. So no critical. You take any cantilever. Tell the answer. Math for 1 meter strip. Maximum BM. See, last time remember, find the pressure here, 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 find the pressure here. Then you get loading like this. Then A plus 2B by 2 into H is the load. A plus 2B by A plus B into H by 3 bending moment. This time UDL, very happily, it is 306.1225 into 1.15 into 1.15 by 2 is the bending moment. Tell the answer. Bending moment in kilonewton meter. That's why I took UDL. So that, see, our principle is bending today, not the calculation. Uniformly varying load or when pressure is non-uniform, thoroughly we consider in master question. You go through that question 100 times if you want. So that this is cakewalk. See, because my purpose is to teach basic. A person you want to learn more, go through same class again and again. Go through same class again and again. Or you do it without seeing anything. You go through the class, make a note. Then do not see the class. You take a paper and fully solve, compare. When you get solid grip, you can come and compete with me then. Answer. 202.42. ಸುಳ್ಳು ಹೇಳ್ಬಾರ್ದು. 202.42. Now, therefore, mu equal to 202.4 into 1.5. Answer, mu, fast, kilonewton meter, mu. Little fast give the answer. Give the answer little fast. Don't waste time. Camera moved on. Ayyo. Yes, because 1 minute now. Okay. Because of the wire. 1 minute. I should hold. Actually, what I do is near the camera for the wire, I put some weight. I forgot today. If a weight is there, then what will happen is when I pull the wire will try to move, but that weight will push the wire down. Therefore, mu into normal reaction will give frictional force. So unless I pull by a force more than that weight into mu, wire will not move. So I take care that way. Some will tell this person has become mad. If that much structure, see when I eat also, I feel that punching, shear, crushing, compression, etc. It naturally comes, not that. Check ಮಾಡ್ತೀನಿ. Okay. Now everything okay now? See, I told what force if I pull the wire, the camera will get disturbed. Now I put the weight there. So friction coefficient counts. What? Someone will surely comment. He has really gone mad. 303.64. 303.6. Start. Now remember, your D equal to take for this also 25 torque. If I take 25 for D equal to, I told last time, lengthwise bending steel is here. This steel is perpendicular to it, placed upper side. See, lengthwise steel when you provide, this steel is placed up above that. I put sketch last time. 800 minus 50 minus 25 minus 25 by 2. Tell the answer D. Tell the D value. Actually, 25 torque is not required. I will do one thing. Today I will take 20 torque. Yak sumne. 20 torque sufficient. Minus 20. This is 25 only. Actually, this also is not 25. That also is 20. Correct? You can do one thing. See, but no. Tomorrow we may change it to 25 torque. So we will stick to it. Answer. See, someone will tell, you took 20 torque. No. Tomorrow I may change it to 25 torque. Therefore, let it be 25. He will tell, tomorrow you may change it 25. I am not changing. I know it. Answer. D. 75, 95. 705. 715. 75, 20 by 2. Oh, 20 by 2. 715. Tell the answer. What is mu limit? 0.36 into xu max by d into bracket 1 minus 0.42 into x max by d into b is 1000 into d is 715 square, fck is 30. This is in Newton millimeter. Convert to kilonewton meter. 100% not by hearted. 0.36 fck is the average stress. D minus 0.42 xu is the lever arm. Then D minus 0.42 is the lever arm. Then what? Force is what? Point B into xu is the area, which on take D outside, it will come to QBD square format, where the lever arm MR constant is 0.36 fck into 1 minus 0.36 xu by D into 1 minus 0.42 xu by D. Xu by D equal xu max by D. Beda. 715. Ayyo, what is this? What is this? This is moment for the full width. Do you think I don't know that much? When I take load in kilonewton per meter square, I am finding BM for this cantilever. For this cantilever, I take a strip of 1 meter. So when you take a strip of 1 meter, load in kN per meter square will become kN per meter. Earlier it was changing. We multiply that 306.1225 into what? Oh, sorry. It is not 306.1225. So what is this? It is not 306.1225. It is how much? Tell me. What is the load in kN per meter square? Wrong reading. That upward pressure is 122.449. Correct or not? Correct? That upward pressure is, see there, I can see there, 122.449. Yes or no? Tell me. 122.449. Yes. So thank you. Actually, I told kN per meter square. See, you are not alert. You should have told at that time, sir, that 3 something is for entire width. I want this way bending. I want for a strip of 1 meter. For 1 meter strip, load should be in kN per meter square. See, someone should have surely commented later, but he can make out that it is a misprinted value. He told in the class that pressure to be counted per meter square. By looking there, he only wrote the answer. Number got interchanged. It is not called technical mistake. I have that much knowledge. I will not use that upward load per lengthwise bending per meter. Lengthwise bending for full width. This is widthwise bending. I want strip of 1 meter. So BM is changing. What is the BM? Okay. Anyway, thank you for saving embarrassment of people commenting wrong. Not wrong. They should tell misprinted. There's a limit for me also. See, I saw 3 something. But one thing, there was slight distraction because of IPL you talked. Otherwise, SBC is 150. When SBC is 150, how net pressure can be 300? If I thought that way, I would have make out. But because I want to finish fast, I wrote the number. Answer. Bending moment. 80.97. Okay. 80.97. Factored value. That's why your involvement will help me from some embarrassment. Not technical embarrassment. Calculation or misprinted embarrassment. People are there who are waiting for such things. They will think, I want to find a mistake so that I can highlight it in front of everybody. I want him to lose the face. Okay, let me see. Who is that person? 121.45. Okay. 121.45. MU limit, how much you told? MU limit will remain same. MU limit will come. How much MU limit? MU limit 2115.9. Oh, 2115.9. Like 2000 rupees odd you have got. Bill is only 120 rupees. Why? Because widthwise bending is not predominant. It will be predominant in the next example. Next example, see, lengthwise steel will come lesser, widthwise severe bending will come. Okay, start. Therefore, okay. Why okay? Because MU less than MU limit. You write. AST calculation. Start. MU, how much? MU is 121.45 into 10 to the power 6 equal to 0.87 into 415 into AST into D is 715 into 1 minus AST into 415 divided by 1000 divided by 715 divided by 30. Will solving, you get AST required. Answer. You get AST required in mm square. Answer. It is most probably less than minimum. Minimum is, I forgot now, 15. I forgot that minimum number. I will calculate. 0.85. And now it will change. 0.85 into 1000 into D is 715 divided by 415. Minimum is 1464 for this D. 1465. Minimum is 1465 because D is changing. Answer. AST required. What is AST required? 475. Is it only 475? Correct. Somebody told the number. Is that AST required 475? Tell fast. Is it 475 AST required? No, somebody typed 475. Is it AST required? Yes, okay, 475. Minimum. Therefore, provide minimum. Minimum. Okay, how much? 1465. Now, 20 torr don't waste. Okay, 20 torr spacing. Answer. For 1465 steel, 20 torr spacing, you will give very late. Pi by 4 of 20 square divided by 1465 into 1000. If I wait for you, you will take hours together. 214.44 or 16 torr if you take. It is 137.24. Okay, this is better. We will provide how much? We will provide 16 torr at 125 center to center. Okay, clear? Little liberal. That is this steel. Widthwise steel, we will give 16 torr at 125. Tell me, clear or not? Don't tell clear just to, so that we complete the class. Okay, now, very important, check for shear. Check for one-way shear. One-way shear for widthwise bending. Critical section comes here. At what distance? At distance of D equal to how much? 0.715 meter. Then this distance is 1.15 minus 0.715. Tell the answer. This is the critical section for shear. You write here. Critical section for shear at D. 1.15 minus 0.715. What is that distance? First, 0.435 is this distance. 0.435. Then, okay, the shear force equal to, look that side, 122.449 into 0.435. That's all. Why? Look that side, this much load is the shear force. Answer, 122.449 into 0.435. Today, widthwise bending will come very, very safe. Next time, it will severely hit. Next time, these all I will not explain. Next time is next question. Answer, 53.26. Okay. Shear force, 53.26. But remember, this is working load. So, factored shear force equal to, answer, 53.26 kilonewton into 1.5. 53.26 kilonewton into 1.5. Over. We are ending this one. 79.9 or 80 kilonewton. Say per side. 80 kilonewton. Okay. Now, go to Excel. Go to Excel and type VU equal to 80 kilonewton. And very important, capital D equal to 800. Clear cover. Tell me, how much are you type? Think a little and tell me. Don't type 50. If you take 50, it will take D for that bar. For this bar, I should change the clear cover to how much? Tell me. I should change the clear cover to how much? Because your Excel should take the correct D. Tell me. For this bar, clear cover is not 50. 50 plus one more bar is there, lengthwise bar. This bar comes after lengthwise bar. Tell me, how much clear cover I have typed? No, clear cover, not effective cover. Clear cover, 50 mm clear cover for lengthwise steel. You should type 75. Tell why? 50 for lengthwise bar, then you add that diameter of 25, 75, then it, and now type steel, how much? AST. Type AST, 16 torr at, what was now? 16 torr at, where is it? I rubbed it out. Ayo, I rubbed out. How much I told? Provide steel is 16 torr at 125. How much steel I provided just now? 16 torr at. I forgot. I think 125. Somehow faintly I remember. We provided 16 torr 125, I think. 125. Over. At 125. Okay. Then over. Tell me. Now, use Excel. Those who are serious can do TOWI, PT, this one, that one, table, etc. Use Excel. So, Mr. Nandakumar is in charge. Tell the answer. How much is TOWI and how much is TOWC? Fast. TOWI is danger. TOWI is danger. TOWI is the bill. This is your money, your pocket money. TOWI. Nandakumar, fast. Go to Excel and tell TOWI. Go to Excel and TOWI. Tumba late on. TOWI. Actually, by this time, I will finish by manual 0.119. That is, you got a bill of 119 rupees. Okay, tell me, what is TOWC? Your bill came 119 rupees. When you count the money in the pocket is how much? Money in the pocket. First of all, some will tell, he talks about money matter, 0.398. 0.398. I will tell, you keep quiet. You don't talk as if you know all the basic concept. Then answer my questions. He will, sometime he will tell, oh, this is confusing. Then keep quiet. Okay. Bill is 119. In the money, nearly 400 rupees. Safe or unsafe? Tell me. Since if I talk money matter, doubt will never come. Safe or unsafe? Safe or unsafe? Today safe. If the width of safe or unsafe? First. Oh, this much time. Therefore, safe. Over. Safe. This will complete. So, when I go for detailing, you should tell me left side bottom. Ayo, who remembers now? Forgotten. Left side bottom 20 tor at 100. Right side column bottom 20 tor at 100. Between the column top steel 25 tor at 20 tor at 125. And lateral bending under both column widthwise, you should tell 16 tor at 125 when I go for detailing. Understood now? Make a note. So at that time, don't keep on opening the pages. You should write these things. See later. Same way, decide for last time example also. Now fully clear? Fast. Full clear or not? Full clear. Okay, now what is that one? This, see, long back I pressed once. Okay, put live score update for all future matches. Suddenly the display came there. RR choose to bat. 2-0. Okay. That is IPL started, I think. Let it start. Now, you have to go for the case of when the columns are very, very nearby. It happens sometimes. When the columns are very, very nearby, then you need offset more. Too much offset you should not give. Then width you should give more. Then your lengthwise will fully sag. Your BMD will come this way and widthwise heavy bending will come. This is the last example for learning, so that when you go for ETABS&SAFE, whatever case comes, you should tell, I know it. Whatever case comes. More high, see, first question, high sagging gear and low hogging gear. Second question, medium sagging, heavy hogging gear. Next question, full sagging, no top steel. Then lateral bending same, this way. Earlier questions, light bending. Next question, severe bending. So when you move the cursor or etc., if these are all known for you, you will become almost expert in preparing the model and giving result and what? Going for a good structure engineer, going to be a good structure engineer. Not just what? I know ETABS, how to do a model, I know how to give steel. But do you know what is the meaning of that one? No. Then it is a most dangerous thing to do. Designing and giving detailing by a person who does not have all the idea, it is actually dangerous for structural engineering field. People will not agree. They will tell experience counts. No, experience will not count. Experience counts for speed. Basic knowledge counts. Always remember, basic knowledge counts. That will never let you down. If you got a good basic knowledge, you will never feel, if some inquiry comes, you can shock him by your answers. Sometimes you will tell, hey, this all you know. Yes, I know it. He will start giving you more respect. See, in the design office also, people will give more and more respect. I don't want name. There's a person who undergone everything from me. He is telling, people are afraid of him now. Even people from IITs, in the big, very big firm, they are telling, he told me, not directly, sir, they also come to me for clarification. Some of them asked, where you learned all these? But dedication required. Only by studying will not work out. Everything I told you should think, so that approximations will come. Okay, now go to last example. Tell me. 8, 10. No, I am not for IPL matches. You decide what you want. Another 50 minutes time is there. If you tell continue, no problem. I'll give the question so that I'll draw the diagrams and continue. Or if you feel, no, once in a while comes, 1 week, all this time is over, this 1 hour does not matter, you can manage next time, you can compensate, means your choice. Tell fast. One person long back commented, IPL finals. You decide. Who are there present, I will consider their views. Those who are watching recording, if they tell, sir, you should have continued, then come live and tell. Those who are seeing recording, they should watch whatever given to them. They have no choice. Not clear. What shall I do? You should decide fast. I do not want to tell something here. People watching IPL there. You should see people watch IPL. Oh, 4. Then, so what is telling? Shear force. Okay, Mamul, as usual. Decide fast. You are not doing anything. If you want to stop the class, tell me stop. Okay, sufficient for today. Next time we'll manage means okay. I will also take rest. What is there? Or no, sir, we will study more. See? No answer. You are not hearing anything. See?
No, sir.
At least reply. Because someone told earlier, so IPL starts. Now I told earlier. Now go for, instead of telling widthwise bending, answer came, go for IPL. 12 for 0. 12 for 0, how many overs? 12 for 0 in 2.3 overs. Jaiswal, Butler. Okay. Oh, not. No, I want comment from those who are my regular batch students. No. Those other comment not considered. No. If you are watching in YouTube, it is not that I am not giving importance to you. My importance is for those who are in the batch. Okay, then I'll continue. Okay, IPL, what later? See, for me, no problem. Or I can bring to a stage and continue. See, I told someone commented there, continue. I am not telling, I am not considering you. But for me, even if it is a public class, important is those who are in the group. Okay, now, next question. I prepared during the break just now and wrote it here. I will not see anything, don't worry. See, nothing is there. See here. This is first. I made a trial. I did not get the answer. I cancelled it. I made a second trial. I achieved what I want. You can see that's all. See, it includes complete SF diagram, BM diagram, everything, roughly. But why means I don't require diagrams for that one. So I'll give the question now. See, now, like last time, same way, see. A person in design office is asked to design a combined footing for 2 columns. See, for 2 columns. I start it so that way at least you can save the time. IPL will come. Watch simultaneously what is there. Then, how much it is? I forgot the width only. What width I have taken? 3.25 I think. 1 by x bar is how much? Okay. 2.5, 1.92. Okay. This is the footing plan. He decided that in the available space for this combined footing, he told the best I can do is this way. See, this is center line. Now, one column is like this, but other column is like this. Due to some reason, other column is placed this way. A little more space. 1 minute now. I want to see that it is within the range. It is within the range. Can you see? Is it within the range? Yes. Now, the distances he finalized is, this is your column 1, column 2. He provided the spacing of the two column is quite small, only 2.5 meter. Okay, this column should come nearby. See, this column should come nearby. Now, see, this is the column, footing. Okay, the spacing between the two columns is 2.5, means very close spacing. And available space he provided here, this side for 2 meter. That side he gave for 1.9 meter, little lesser. This column load is 1300 kilonewton. This column load is 1200 kilonewton. And column 1, column 2. Full length of footing is 25, 10, 35, 45, 65, 6.4 meter. And width of footing is little bigger, 3.25 meter. Oh, because he has problem lengthwise. See, he has lengthwise problem. So he adjusted that one by providing more width. So now, if I cut here, if I break here, both will almost behave separately like what? Two isolated footings. Okay, now, further data, he told what? For this one, we decided to use M30 concrete plus FE 500 steel. And further, SBC report is showing, SBC, I wrote SBC somewhere here. SBC, yellow bardanu. 150 kN per little weaker soil. Someone told 140 kN per, I don't know, I'll just check it. Why I don't want to change the SPC later. The SBC, the soil is little weaker, only 140 kN per meter square is the SBC. This is my imagination. Now, this much he proposed, and the column, see, this column is, width is 300 millimeter by lengthwise is 500 millimeter. This column is 200 millimeter by lengthwise is 600 millimeter. These are the arrangement. He is asked to design the combined footing. He found area required. Then he saw the adjoining footing all. What space is there? He managed to place this much length. Widthwise, he made 6.25. Then he told, arrangement is okay. Pressure is under control. You can proceed further. Because today is my last day in the office. Tomorrow I am joining somewhere else. Now, but still, we don't have enough, we have doubt. So, first, put a lengthwise diagram. One load here, one load here. Couple not there. 1300 kilonewton and 1200 kilonewton. This is 2 meter, 2.5. This is A not required. From here, tell me X bar from left hand equal to 1300 into 2 plus 1200 into 2.5 plus 2 is 4.5 divided by 2500 is the load total. Answer X bar from left hand. Answer. X bar from left hand. Answer. At least let us proceed further. See, if you want to enjoy IPL, enjoy closing part. Actually, you want a thrill of that winning and celebration, I think. Who wants to see the batting unnecessarily? 3.2 meter. Okay. 3.2 meter is X bar. Now, or this length is 6.4 meter. Midpoint from either side is 3.2 meter. Oh, surprise! Here also resultant cost of the footing. So M1, M2 both are 0. Only P. Therefore, uniform pressure. Clear? Purpose is to save the time. I said the question. Okay. Uniform pressure. Or those who want confirmation. See, these two loads, when you transfer to center, it will become 2500. This will create a moment of 1300 into this distance. This will create a moment like this of 1200 into this distance. Right? Both will be equal, means one anti-clockwise, one clockwise, balanced. Finally, you will get only P. Therefore, tell the answer. No question of what? P by A, M by Z, nothing. Simply PG, PG everywhere equal to 1.1 P by area. 1.1 into P is 2500 divided by area is 6.4 into 3.25. Tell what is the gross pressure. See, M1, Z1, nothing required. People will tell, you are making easy. Yes, my purpose is not your pressure diagram or trapezoidal loading. My purpose is bending nature. I want lengthwise bending to produce only sagging BM and heavy widthwise bending. That is the purpose. 10 hours I spent for first question. Answer. 132.21 kilonewton per meter square, which is less than SBC of 140. Okay. So you take your telephone and call that person. Call him. Yes, your footing dimensions you provided is perfectly okay. Thank you very much. Thank you. Wherever you go, continue same habit. Okay, thank you. Over. See? It's okay, correctly okay. Now onwards, for any calculation, we need, tell what? We need what? Now onwards, for any calculation, we need, fast. We need, now onwards, for any calculation, you need, forgot, net pressure. Net pressure anywhere equal to P by A, that's all. 2500 by 6.4 by 3.25. Anybody can tell me correctly net pressure in kilonewton per meter square? 6.4 into 3.25 reciprocal into 2500. ಇಷ್ಟೊತ್ತು ಬೇಕಾ? ಎಷ್ಟು ನನಗೆ ಎಷ್ಟು ಬಂತು ನೋಡೋಣ. 3.25 or 3.2, I forgot now whether I taken 3.25 or 3.2. I got a doubt. I think I taken 3.2, I think. Let me check it. Where is that paper? Gone. It is already thrown outside. Where is that paper? See, that paper is thrown outside because I got answer of some other answer. 132.2 is the pressure. It's correct, 132.2. Okay. 390.625. Okay. How much answer? Net pressure, how much? Is it 120.1923? Correct or not? 120.1923. Correct answer? I will make a note somewhere. I may require it. I write here. 1, because later I don't want mistake. 120.1923 is net pressure. Over. Okay, now start. Now, as usual, see, little work for you. Non-stop I am taking. You watch IPL and also give the answer. Those who are serious, try. Those who are not serious, till I come back once again after a small break, you watch IPL. See, consider lengthwise bending and consider 1 meter strip under columns. Now I will not tell sketch. Those who want, write a sketch here. Oh, this is becoming beyond the limit. This much explanation is becoming beyond the limit. Quite nearby. See, it is quite nearby. This way, take a strip of 1 meter under the columns. For that one, lengthwise bending, for 1 meter strip, draw the loading diagram. Point load of no, not 1 meter strip. Consider lengthwise bending, sorry. First consider full width. Not 1 meter. 1 meter later. See, if I by mistake last time I wrote 1 meter, then actually you change it. See, I don't remember now. Did I wrote 1 meter last time by mistake? 1 meter, I see here. No, I have not written anything. 1 minute, I'll check it now. Because mistake means mistake. No. No. I wrote last time, consider entire width. Correct? Entire width only I wrote. 1 meter strip comes later. Consider entire width only. Then only the column loads are how much? 1300 kilonewton. Little out of scale. Then your loading diagram will become here a point load of 1300 kilonewton. Here there is a point load of 1200 kilonewton. This distance is out of scale, 2 meter, little out of scale. This is 2.5. Actually looks very odd. What to do? Or I should further change it now. Okay. ಆಯ್ತು ಬಿಡಿ, ಚೇಂಜ್ ಮಾಡಿ, ಸುಮ್ಮನೆ ಅಸಹ್ಯಾಗಿರುತ್ತೆ, ಬೇಡ. ಸೊ ನೋಡೋರು ಆಮೇಲೆ ಕಮೆಂಟ್ ಮಾಡ್ತಾರೆ, ಏನು ಸ್ಕೇಲ್ ಗೊತ್ತಿಲ್ಲ ಇವ್ರಿಗೆ ಅಂತ. ಆಯ್ತಪ್ಪ, ಪೀಪಲ್ ವಿಲ್ ಟೆಲ್ ಡಸ್ ನಾಟ್ ನೋ ಸ್ಕೇಲ್. ಸಿ, ಓಕೆ, ದಿಸ್ ಈಸ್ 1 ಕಾಲಮ್ ಲೋಡ್. ನೌ ಗುಡ್, 1 ಕಾಲಮ್ ಲೋಡ್. ದಿಸ್ ಈಸ್ ಎಷ್ಟದು 1300 kilonewton. This is 1200 kilonewton. This distance is 1.2 meter. 2 meter. Now okay, this is 2.5 meter. Close column. This is 1.9 meter. Anybody can tell me what is the upward load? What is the upward load in kilonewton per meter? Pressure is 120.1923. That is per meter square. Now I want full width. When you go 1 meter length, load will come for full width. Tell the answer. What is the upward load per meter length? This is upward load per meter length for lengthwise bending, considering full width. What is the answer? Fast. What is the answer? Fast. You are not telling answer. At least something you should tell. What is the answer? Upward load per full width. No, if you don't tell this one, then you don't know anything. No point in continuing class only. Then whatever I shouted for all these days is useless. Already so many escaped. Why? 120.192 is per meter square. What is the upward load in kilonewton per meter if you consider the full width? Length is 1 meter, width is 3.25. No. If you don't give this value, I cannot continue. I know the answer. Fast. 390.625. 390.625. 1 minute. Or you can do one thing. Since the 2-column load resultant passes to center 2500, you divide by 6.4, you should get back same answer. Check it. That see, for equilibrium, sigma v is 0, down 2500, total upward load should be 2500. So divide by 6.4, you should get back same number. Are you getting or not? You should get back same number. That's a check for you. This I told you earlier, sigma v is 0. If sigma v is not 0, you cannot draw SFDBMD. Getting the same or not? First. Are you getting the same or not? This much difficulty, wasting lot of time. You are wasting lot of time. Just to answer yes, same answer comes. It has to come in my class. No escape for it. Answer illa. This way if you respond, very difficult to take the class. All are watching IPL, I think now. Who is out? How much Butler scored? Butler got out, I think, most probably. Butler is gone. Good. Butler is still there. Sanju Samson. I asked a question. And no reply is coming. Then I want 2 reasons I told. 1, to ensure your involvement. 2nd, to check any voice problem is there. Okay. Same. Thank you. Now, as usual, this is A, this is B, this is C, this is D. Draw the shearing post diagram and bending moment diagram. You can draw it now. Tell me fast. Can you draw or not? Okay, start. I'll take a small break. I'll come back after the break and tell you, decide the depth of footing. I will make it ready for punching shear. Then, can you check for punching shear and give the value next time? Okay, that is okay. So that, otherwise, if I check here and do it, only 10 minutes left out. Okay, that much early I can leave. After SFDBMD, I will fix the depth and make it ready for punching shear. So punching shear check you can do it means then next time you can continue because already 8:30. That's okay. Okay, therefore, see, at least you are saving 1 hour for next class. Otherwise, next class, again I start from beginning. I will draw the diagram. You tell me correct or not. Don't tell me correct just like that. Everything I want. 781.25. Hope values are visible. 781.25. 518.75. You complete everything. $457.8125. 457.81. 742.18. 19. 0. This point required. This is A, this is B, this is C, D. A point called E. I want distance from here to here and here to here. Use whatever you want. It is coming 1.328 meter from here. 1.328 meter here. From that side is coming 1.172 meter here. Now, Draw the BMD. I will sit below and write. Now what will happen is, see, for bending moment diagram, BM at C equal to 0 equal to BM at D. BM at A will come plus. BM at B also will come plus. And even BM at E also will come plus. That means all sagging, no hogging BM. So calculate, draw the BMD also. Or BMD on tension side. This is, it is 781.25 here. There. .705 positive means sagging. 705.08 there. Even here also positive. Positive means sagging. Everywhere tension down. That BM is 390.625 into bracket 1.328 plus 2 close square divided by 2 minus 1300 into 1.328. You can, it is positive 436.8. So your BMD will come this way, this way, this way. Now this is the point of not maximum BM, it is the point of minimum BM. So here full will sag, no hogging, nothing. Everywhere you require bottom steel. See, therefore full you require only bottom steel. Okay, start. This you write yourself only later. Then now consider 1 meter strip under columns. That is, you put a sketch of this type. Sorry, I'll continue further so that you can work out. Okay, this way. 1 column here, 1 column here. Take a strip of 1 meter. Now, for that one, draw factored BMs. Get factored BM. Factored BM. How to get 1000 times told? This is the BM values for one full width. You want for 1 meter strip. When you want for 1 meter strip, what will happen? Divide those BMs by width of 3.25. But you increase by how? Divide by 3.25, multiply by 25, 1.25, increase by 20%, and also factor by 1.5. So your though that BM will come. This is little bigger. Okay. Now see, overhand BM is very bigger. This will come. ಎಷ್ಟು number ಅದು? 1 by 3.25 into 1.25 into 1.5 is 0.57. Yes. Store A. If I use that one, 781.25 into shift store A. Shift store A into 781.25. This will be 450 point per meter strip. 72. This is 705.08 into shift store A. 406.78 or 451. Who want changes? 407. Round off the numbers. Don't waste time. Round off to next number. Is 252 here. Then first fix the depth based on bending. Equate mu to mu limit. Get the value of D required. Now I will not waste time. Why? We are doing 100 times this one now. Highest BM you have to consider. For that one, consider the maximum mu of 451. 451 10 to the power 6 divided by 0.36 divided by 0.46 divided by bracket 1 minus 0.42 into 0.46 divided by 1000 divided by M30 concrete. 30 equal to root answer. Depth required came 336.44 millimeter. Now we will take 25 tor at a clear cover of 50. So capital D required will be plus 50 plus 12.5 will come to 397.9. But accounting for shear will increase by 75%. Therefore, your D will come approximately into 1.75. 696 point something. So with these values, we will take capital D equal to 700 millimeter. If you take 700 millimeter with the 25 tor, your actual D provided will be 700 minus 50 minus 12.5 is 637.5. Okay, now check for punching shear. For punching shear, now only. For punching shear, I should not explain too much. I will write a sketch where both I will give in the same way. Last time, one column here, one column here, this way. Okay, now this column load is 1300, that column load is 1200. Critical section will come this way. Critical section will come this way. Then this is 0.3. 0.3 plus 0.6375 is 0.9375 is this number, and this number is 0.5 plus 0.6375. 1.1375 here, and here this side is 0.6 plus 0.6375. 1.2375 here, and this width is 0.2 plus 0.6375. It is 0.8375 here. And if I check here, your VU will come, your VP will come. Here also your VP will come. Pressure is 120.923. Correct? Is the pressure correct? 120.923. What is the pressure? 2500 divided by 3.25 divided by 6.4. 120.1923. Okay. 120.1923. Okay. See, some small mistake. Then correct. The VP here will be 1000, where is the load? 1300 minus 1.1375 into 0.9375 into 120.1923. You don't do this way, you do systematically. Don't try like me. See, that's what, if I am designing, I won't write anything first of all. If somebody comes, please design this one, I will keep on entering the values. VP is 1171.8. VP there is 0.8375 into 1.2375 into 120.1923. Subtract it from 1200. VP here is 1075.43 kilonewton. So VUP here is corresponding here 1171.8 into 1.5. 1757.7. There 1075.43 into 1.5. 1613.15. And tau VP here, danger number. This is a danger number. Tau VP is shear stress. How much is the bill? Bill coming here is 1137.5 into 1137.5 into 2 plus 937.5 into 2 into effective depth of effect depth 637.5, that is the resisting area reciprocal into shear force of 1757.7 into 1 10 to the power 3. Point danger number 0.6644 here. There shear stress is 837.5 plus 1237.5 into 2 into effective depth of 637.5 resisting area into 1. Okay, I made into 1 unnecessarily, into 1. Okay, reciprocal of that one into shear force of 1613.15 10 to the power 3. It comes to point danger number here 0.6097 here. Whereas now allowed beku here beta c equal to 200 by 300 500 0.6. Here beta c equal to 0.2 by 0.6 0.3333. Here both the places I forgot, sorry, beta c equal to 0.6 here, beta c equal to 0.3333 here, and both the places tau c equal to 0.25 into root 30. M30 allo, M30 yes. 1.3693. Then Ks here and Ks here. Ks here is 1. Why 1? Why 1? 1 because 0.5 plus beta c will come more than 1. If it is more than 1, take 1. Here Ks equal to 0.8333. Because of that one, tau Cp here. This is money in the pocket. Money in the pocket. Tau Cp here is 1.3693. Tau Cp here is 1.1410. Both of them are safe. Why? Stress is 0.66, allowed 1.13. Or in the ETAB number coming here, I write a number incoming in the software ETABS&SAFE. When you do by ETABS&SAFE, the number coming here is 0.495. 0.4952 here, and number coming there is, see, I have not looked at you for a long time, 0.5345. That shows that safe. Next you have to go to, next continue and go to, now tell the answer, now go to, first, go to either longitudinal reinforcement or Indian Premier League. You decide. Now go to either longitudinal reinforcement No, such questions, no time now. I can't answer that question. It has got delicate point. If width of column is more than 1 meter, then how much width of footing is considered under more instance of column loads? For that theory is there. Actually in RCC class I told the theory that beta C, Ks, why it is considered, what is the reason for beta C, why you take 0.5 plus beta C, why beta C short side by longer side. With the example I have shown the variation there. And told, now no time. Here I can't discuss such things. Suddenly someone comes and asks doubts. No, there is no time also. That is told in the RCC class. Ask anybody in the RCC. I told the real meaning of the dispersion. When the column side is too long, I told what happens. I told in the class, sometime column can be 1.25 meter. If it is 1.25 meter for punching shear, what you have to do? I told in RCC class. Here I can't repeat, sorry. No, that much I can't tell. You ask anybody who came into RCC class, did I explain or not? They know it. RCC class already over. Now no joining. Next is next batch only. Because all classes are deleted. RCC class, except column and footing, not column footing, except some part, almost all are deleted. Okay. You can contact me personally and ask. Because here I can't discuss about courses all. Okay, tell others what to do now. Go for steel. Okay, now do one thing. Only 10 minutes is there. I will stop, but I will keep the class on for another 5 minutes so that anybody can comment. Yes, got all the values. That shows real dedication. That shows your dedication. My number, you can see that in the brochure, you can see any demo class there. Any demo class you can see in the brochure. Or you go to KS and KSL structural engineering classes. There you can see some places, so many in the playlist. You go to demo classes. In the demo class, I displayed my number there. I won't want to tell here. In the demo classes, I displayed my number. From there you can take it. Demo classes, you see any demo class, either for RCC or for ETABS&SAFE or for steel, I not put demo class, RCC or basic structural knowledge, 5th semester, 1st semester, so many demo classes are there. There you can see the not brochure. In the board I written here, big letters, my number. That number you can send WhatsApp message. Okay. Now at least some of you who are serious, tell me if all answers are coming. So then we will continue. Okay, thank you. See, someone told, sir, got all the values correct. Okay then. Then no point in continuing. I will close. Why? Unnecessarily make the class longer than required. Okay, thank you. See you next time. So, YouTube class, one more Saturday class is there for 2 hours. Okay, because little portion is pending now. So, coming Saturday, actually today I wanted to finish, but I know sometime I think I can finish, but I know my limitation. What limitation? Not structural knowledge. I tell repeatedly again and again. So many things I explain second time, third time. So 2 hours. Next Saturday will be the last class in YouTube. Sunday onwards, group class only in Zoom. That is, we are changing over to software side. Okay, thank you.